good, dunce? How are we? Some spring or some mass spring damper physics programming stuff is what we're doing today. Seems easy enough to implement. Hopefully. Just some calculus. Now, I do have a new camera position set up. The camera's a little bit higher than it used to be. But that's only until some more stuff gets delivered today. Yeah. Still doing character controller. The character, like, the movement stuff, the movement for the character is basically sorted. Um, this is more the physics um for the items we interact with. So when we grab onto something, that will have a mass spring damper that determines, how strong the spring is, like how strong the connection is. If when I move, does it like trail and does it like bounce and that type of stuff. Um, this stuff. So it's this kind of thing here where you increase the mass. You can see how it's doing that. You can see how it's underdamped. Ah, yeah, that's right. My bad. My bad. Let me move chat down there too. Um, so it's this stuff basically. And you can see how if we increase the spring constant, it alters. And if we increase the damping, that's basically what we want right there. You grab an object, it moves into the hand, and then it's stuck at the hand, sort of thing. The player grabs onto something. As the player moves, it moves that. I was gonna do that. I like auto mod. Auto mod is fantastic. Um, but yeah, and you see how you can like have it for different things. So overdamp it, and it like moves very slowly into place. So you want to get it. You want to get it like really tuned around here, like right on the border of underdamped and overdamped. So that way it's like really smooth going into position. And then as the player like moves, the item they're holding is pretty stuck to that spot. Yeah. That's that's the idea behind it. And that's the math for it. So we need to figure out how we're building that today. What up, Bongo? How you doing? And Sammy, how you doing? I also need to rearrange my living room at some point. So like, how big is my living room? Say it's probably 8. Nah, that'd be probably 9 or 10. That would be maybe about 4. Number 4. Probably bigger than that. I'm just kind of doing it by eye at the moment. Doing good. Most productive week ever, game dev wise. Actually learning. Dude's just remodeling on his stream. Not remodeling. My. I don't know if this is normal. Who here has carpet in their property? Does anyone have carpet? You do, Vongo? Okay. Where it goes to the wall, like where it meets the wall, my carpet, when it gets to the wall, does that. And it's got this bump there. And that's around my entire wall. So I can't put anything against the wall because it tips forward because of that weird ass bump that's going on. I think here is what I think has happened. Okay? Here is what I think has happened. There is wood flooring underneath the carpet. But and that wood flooring where it meets the wall has some skirting. Yeah, has some skirting on the edge. And instead of removing the skirting and laying the carpet, they've just kind of put the carpet down and then like had the carpet go on top of the skirting. I think that's what they've done. It's baffling. It is baffling. G'day, Cam. How you doing? Carpet flooring. Bump. Rise. Something. I had carpet, don't have it anymore. Thought it'd be easy to clean that way. But that's not how it works. Yeah, it's not how it works. Although keeping carpet clean's not very easy either. Especially when you're like me and you don't really dust. Like, I don't dust, so every time I like jump on my carpet, like there's like I vacuum like every few days, and there's still just dust in the carpet. It's like I need to get like an industrial vacuum cleaner and just um this is ripples and stuff. Improper installations such as not tacking strips down, not tacking strips, or not stretching the carpet correctly. Yeah, so I think that's what's happening. Because, like, it should be flush. It should be flush, but it's not.
Yeah, I'm so cursed. So instead of going via London, I'm now getting sent via Dublin.
Wait, your flight's tomorrow. Where are you? Are you going to America? Need from time to time take it outside and clean it properly. What, carpet? You can't just pull carpet and take it outside. You're thinking of a rug. You're thinking of a rug. What up, Munglo? How you doing? How are you doing? We're looking at spring damper physics today, um, which I now know is what you were talking about when you said like create a spring for the things you want to interact with. I now know that's what you were talking about, not it was like every time someone mentioned creating a spring, I was like, are we talking spring bone or are we talking spring arm? Because they're the only two things I know of. But apparently, it was mass spring damper logic stuff. So we have Wallaber to thank for that clarification. Wallaber's the one that clarified it was spring damper, like mass spring damper stuff. British Airways cancelled your flights. They're putting me on another airline. As long as it's not Ryanair. I don't even know. I've never even been on Ryanair. I did test the 4.7 rigid body based movement today. It seems everything works as long as you don't touch the transform outside physics process or integrated forces. Yeah, yeah. Which I think is ridiculous considering you can touch something that isn't the rigid body's transform and it still breaks it. Because you've got to remember that when I was rotating the camera, it still did that. So it was a little bit annoying. Disappointed because I was meant to be going on A380. I mean, what's the difference between that and what you're going on now? What, are you going on an A370 like a peasant? It's a double decker plane. Yeah, but that only matters if you're paying for like the privilege to be in the good area. I never mentioned spring stall. I haven't used it at all. Okay. It might have been Pixel that mentioned springs. I'm pretty sure you mentioned springs. Hang on. I swear you mentioned springs.
I paid for the privilege. You want to know why?
Not really. Go for it. Tell us. Tell us about it. No, you're right. You didn't. Jeez, I'm going insane. I could have sworn both of you mentioned springs, but maybe it was just you replying to Pixel when Pixel said something about springs. Huh. Well, there you go. There you go. I could have mentioned them too at the beginning. Possibly. I don't know. I've been getting everyone mixed up at this point. White. Need I say more? Never. If you're white, you don't need to say anything at all. But you'll have to forgive my lisp, okay? Whenever I'm talking about white and wrong, that's the only word that I mispronounce, okay? Old age is getting to me, Tricky. Old age is indeed getting to me. Since my stuff is multiplayer, I push forces to the host manipulation. Interesting. Well, what I want to do is I want to create a object. Um, create that one. And we also need to create a mass spring damper header file. Also need to copy that, paste it in here. Up here, go like so. Bam. Now, I'm looking forward to this new stuff getting here today because I've got some. Where are we? Yeah, sure. Sure, that's my postcode today. I bought a microphone stand, like one of these kinds of things. This exact one, actually. I bought one of these. And I'm using that to hold my webcam. Okay, I'm using that to hold my webcam. Because that way, my webcam doesn't sit on my desk, so when I bump my desk, the camera won't shake. But the problem is, it doesn't sit at the right height. Yeah. So, what I need to do is I need to get a microphone stand adapter thingamajig. It also doesn't have the correct attachment for my webcam. So I've got this coming today, right, this thing here coming today, which has all these different attachments and a bit of an extender and stuff, so that I can like have it at a good height. Because currently it's up a bit higher than me, so I need to like get it shrunk down. But then the other issue is that issue I mentioned before, where my carpet, when it gets to the wall, goes up like that. So my camera stand is like close to the wall, so it's tilted forward a bit. Which means it's touching the desk. So if I shake the desk, it shakes the camera, which kind of defeats the purpose. So that's why I need to rearrange my apartment so I can put my streaming setup in a better spot. Put it somewhere that doesn't have to deal with that. And I'm thinking, what if we have this? So let's say that's the apartment. Well, that's the living room. It's not the apartment. We have hallway there. We have a doorway there, sort of thing. Yeah. It's like 9 meters, 4 meters. ish. It's about 4 meters. It might be 5 meters. I haven't actually measured it yet. Yeah. We've got PowerPoints there, and over here. Okay. Currently, I have a side table thing here, which is where I put like my water and my glass and stuff. I've got one desk that goes along here. Another desk goes along here. And I've got a bookshelf cabinet thing there. And that's also where my internet is, my Wi-Fi and my router and my modem and stuff. Also got green screen stuff along there. So I've got stuff here that I need to throw out. Got stuff there that I need to throw out. So I need to rearrange this. How many desks do I need? Honestly, I think I need another. If I'm being honest. Nah, I need to stop. I need to like not have a desk and instead have like another cabinet or something that I can put stuff in. Another room. I've got my bedroom. That was tasty. So what I'm thinking is just got that tower and I've got that tower. That's the only issue, is figuring out how my towers are going to go in this new configuration. Because I think this is like 170, 140. This desk is 140 long. You have two PCs? I do. I have my new PC that I got like 2.5 years ago or so. And I've got my secondary PC, which was my main PC before I bought the one that I use now. So, yeah. I have two. I did have three. But that one had a 1080 GPU in it. And someone I worked with like needed to upgrade their system like a couple years back, or a few years back, and I was like, sure, here you go, you can use this one, you can have this one. As that they wanted to buy it, so I told them like $500. I don't care, I don't use it. Have it. So what do we need to do? Because I could put one desk along here. But then we're going to have an issue if I want to use that one as the streaming PC. Unless I put it on top of that. That could be an option. Move you up there, put you underneath. That's possible. So we do that. Not going to be that long. It's going to be like that sort of thing. Have that there. We have. No, I can't do it that way. And the reason being is I'm gonna have the same issue with cameras. Like with the camera stand and stuff like that. What up, Footlong? How you doing? For me, less furniture feels better. Yeah, but I've got so much stuff. Like the other desk has like my soldering kit and stuff like that on it. Like the soldering mat, the solder, the different bits and pieces, the light and the lamp and things. So yeah. um you use it once a year. I don't remember the last time I used it. It's been more than a year. um if I have the desk there, I'd probably move it out a bit actually. Probably have it like that. Microphone, light. Gotta remember that. Um, and then we do have another light there. But I feel like instead of having those two there, I feel like we can have a light there. And keep that there. Then we can have like light here. Light here. That's the only problem is like it locks me in. And that's an issue. What up, Sammy? Assuming you have some basement where you can hide stuff. No, I'm in an apartment. There is no basement where I can hide stuff. Yeah. Ooh, you were eating Chinese. Oof, that sounds good. I had Chinese the other day. Now, I want to include. Is it under core? I think it's under core. It is. It is. Yes. Your apartment doesn't have storage. That's weird. It's not. It's not a huge apartment building. Like I'm not. It's not like a 20-story apartment building where everyone has like a small storage in the basement or something like that. It's like a 3-story building that has like 12 apartments in it, and each apartment is relatively decent sized. Like I've got a kitchen that's separate from the lounge room, that's separate from the bedroom, which has a walk-in, like its own ensuite bathroom, as well as a walk-in wardrobe. Like, I can't move from the wall bit and going from the side between the wall and desk. Well, that becomes a problem with the hallway. that comes in. So yeah, what up, Robotic Ninja? How you doing? Welcome in. Mass spring damper. Going to be object, but then that does public objects, and then that does GD class. Now I don't think, actually, yeah, I know. I think that's right. Now GD, well, it's all capital. That's why. We're working on where you go to the when you go to the bullet, it doubles your damage and speeds up time. Doubles the damage and speeds up time. Hi, Hypno, feel free. I am free to judge my code. No. No, I won't. It's taken a fucking long time to load. Very nice. Reloading. On area 3D body entered. If body is in group player. Oh, you're awaiting. You're awaiting in there for 15 seconds. Ew. 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 Like, split this stuff out into another function, and then when the timer times out, call this function, and then you don't need the await in here. Red! G'day, you good dunce. How yous doing? We're just judging Vongo's code at the moment. Right there. Yeah. Rating some poor sap. How dare you? I'm not a sap. I'm quite clearly a human male. Apparently that was the raid message. Rude. Why would you say that? I know, Grumble. It's so rude. Why make it a different function? I avoid doing stuff like this where I can, because you will end up at some point inadvertently putting in an await in the wrong place, which will cause your thread to hang, like your main thread to hang. I'm not set like this doesn't do that. This doesn't do that. I'm just saying that like it'll cause you to at some point do this on the main thread and accidentally hang the main thread. Yeah. Yeah. I was the only one who followed through. How you doing? I'm doing well, thank you. How was your stream? What we up to, Red? We are looking at mass spring damper physics today, so that we can, when our player grabs something, their hand is like attached to that thing, And then you can see here, that's basically what will happen when they pick something up. They'll pick it up, it'll go to the hand, and then it's there. Or if they grab a handle, then as the player moves away, we can like stop the player once it gets to the max length. Or we can have it that when the player moves and they're holding an object, something should slide, it like slides along that way as the player walks backwards or turns or something. That type of stuff. So yeah, if we have this too low, then it does that. And that looks weird. That's not how we want. That's not how we want things to be done. So I was working on the ending cutscene, the true ending, if you will, almost done. I need to decide if I'm gonna have like a true ending or not for mine. Do you think there's any? Actually, no, because that would require nah. I'm not gonna. I'm just gonna have a bunch of different what do you call it? A bunch of different endings, and all of the endings are real endings. They're just yeah. I think I'll make different endings in my game too. Yeah, fair. What up, Avinity? How you doing? Everyone, we do have a secret word here. If you guess the secret word, you get to pick a game from our list of prizes. You get to pick a game from the list, and I give you the key that I have for that game. We just added these ones here. These ones just got added. Are there any hints? There are currently 3 hints. The hints are every game has this. It can be the worst part of any game. And it is 5 letters. Wait, no, it's 6 letters. Yeah, 6 letters. that's shut up, Sammy. Sorry for calling you a sap. It's okay. It's okay. You rated me. You can call me whatever you want. Just don't call me a bedunt. I just googled it and it sounded worse than what I imagined. I'm just hoping it isn't some code thing. Technically, anything can be a code thing. Yeah. You forgot about Gedunt and Bedunt. So what we need to do use possible secret words with these hints. Camera. No, it's not camera. Physics. I believe that's 7 letters, Bongo. System. No. Unfortunate. These are good guesses. Except for physics. That wasn't a good guess. What happened to your music? I decided to try streams without background music for a while just to see how people like it. Because I figure people like to listen to their own music and stuff. And if I'm playing music, then it kind of interferes. How's Arc treating you? It's going well. Haven't really had any issues since I started using it. What, I think I changed over to Arc about 12 months ago now. I was using Kubuntu before that. Yeah. If you want to listen to what I'm listening to, we still have the song up here. If you want to listen to what I'm listening to, your call. So we'll need mass. I think we also need like a vector 3. It needs to be like the target or the origin. Do I need that? Of course I need it because it needs to know where it's moving to. Ending? No. I've never tried Arc. I was going to put it on a laptop. I got through school, but I went with Nix OS. Nix is built off of Arch. So there we go. Distro watch. NixOS. It is independent, but yeah. It was initially built off of Arch. Like, that's how it started, I'm pretty sure. I'm pretty sure that's how it started anyway. Declaring things through the files. Yeah, like it's definitely designed for like a repeatable install. So if you were running a business that used Linux for all of your employees' laptops and stuff, you can just like redeploy the same thing. Hey, Sammy got it. The worst part of any game? Are you saying I'm bad? I said it can be the worst part of any game. I didn't say it is. I said it can be. We all saw the journalist trying to play Cuphead and failing at the tutorial. So. All right. Which one do you want, Sammy? Take your pick. Finally, someone I can nerd out with. You can nerd out with all of us here. We're all nerds. Nordhold? Alright. Alright. Let me get this organized. You gotta stop winning, Sammy. You gotta stop winning. Let me know if it doesn't work too. Do you use a window manager? We all use a window manager. I'm using Hyperland. Yeah. Mass. Spring constant. Damping. I feel like I feel like we need a target position or something. I'm thinking of trying out Hyperland. I'm just currently using KDE Plasma. I was using KDE Plasma before as well. I was on Kubuntu, which was just Ubuntu with KDE. But then I had issues with that, where after a system update, I wasn't able to actually boot into anything. I just had like graphical driver issues. So then I installed Arch. And I was like, you know what, let's try Hyperland. Let's see what all the fuss is about. And now I'm like, damn, Hyperland is fun. It's so nice. Here's the thing about Hyperland. You don't have to use it tiled. You can have floating windows. You can even, if you want to go into your Hyperland config, there's these window rules here. Yeah. These window rules, you can tell them if you want them to float. So you can just say, for anything, make it floating. Make it a floating window. So then all of your windows are floating windows and not tiled. End up trying it out. I'll have to download some DOF files, start customizing from there. That's fair. That's fair. My dot files are basically just the standard dot files. And I've just customized some colors. That's about it. Most of what you see is just me customizing colors. And yeah. That's if I have a target, something very, very basic, not some crazy bloated live wallpaper mess. Yeah, there is. So you can see this wallpaper here. That is controlled by Hyperpaper. And Hyperpaper just says what image you want to have on what monitor. Yeah. And then you can set up a script in a cron tab that like loops over and updates the wallpaper if you want to, but why waste the resources for something you're just going to have covered? Yeah? It's a waste of resources. I'm trying to figure out how I want this set up. Do I want to tell, like, do I want a spring damper to be created on the object I'm grabbing? Or do I want it to be created on the player? Have the calculation happen on the player's physics and then tell the thing we're grabbing what's going on. If I can avoid looking at code, I remember Godot has this stuff. What they do, they create a new spring damper, so it's just an object. They have initial position, initial velocity, initial frequency, initial dampening, and initial delta. Update spring damper. Okay, we pass the target in and we tell it what the delta is. Okay, the updated target position of the spring damper. The current frames delta time. Only pass this if you are not calling the update function as a fixed interval. Return value of the function is the updated position. However, you may wish to access the updated velocity as part of the spring damper. So the spring damper has a velocity itself. So they don't even have mass. They don't even have mass being used as part of theirs. That's interesting. Why not? Well, I suppose that's actually constructor arguments. Interesting. So why do they not have... I would assume mass would be a big part of the calculation. Unless it just treats everything as the same mass. Whereas I'm going to have things of different mass in my game. If it's too heavy to move and stuff like that. You can see how slow it moves. So the mass definitely affects how fast it moves. Like if that was 50 kilos, that probably wouldn't be moving. Or be moving very slow. Huh. So yeah, we'll have the mass. This whole thing on the side that's covering half the fucking screen. Go away. That would be stiffness, damping. And then there's the force amplitude, the driving frequency, initial displacement, initial velocity. Okay. So I'll set up all of these for now. Because if I adjust this, you bastards. Underdamped. I just like that one. Using inverse kinematics for grabbing objects. So there is going to be that Orchrus, but that's just determining the hand position. Yeah. So like that's for basically going, the hand should be grabbing here on the bar. But then when I move, like when the character moves, it's not just the character that should move. Like the hand should stay on the bar, but then we also need to calculate the movement of the object it's holding. Yeah. When item is grabbed, its position should be hand position, right? Not necessarily. No. So if you're picking up an item and holding it, then yes, the item will go into the hand and just go wherever the hand. Like if the player grabs something that's on the ground that weighs 400 kilograms, the player's not picking that up. The player will try to move it, but the player's not going to be able to move. So the hand has to stay on that thing, and then as they move away, their arm stretches And then when it gets to a certain point, the player can't move back anymore because their arm is fully extended. That type of stuff. And also, like, you grab onto something that needs to slide, you want to be able to turn, and then as the hand moves, force is applied to the thing that's sliding, and then that causes that thing to slide while the hand stays on the handle. Okay? All that kind of stuff. However, I need to give you words because it's ads time. And I also need to get myself another coffee. So set that. Be ready. Word. There you go. All right. BRB. Oh, I'm back. What? Grin. Grip, nice. Nice. Grit. Um, Gert. Pint. Oh, I've already got pint. Earrig. Yep. I know what you mean. It's so irrigating. Wait, irrigating is actually a word. Um, do you not do Game Duel anymore? I mean, there's a redeem for it if you want to do Game Duel. But I think we overdid Game Duel. We really overdid Game Duel. Yeah, we beat Game Duel. We don't need to do it anymore. We already beat it. um, because where was it? I think it was a video I saw. It was an integral physics video. Yeah, we'll keep that open. Um, yeah, it was this thing. Damn it, who cares? Skip. Um, so it was this. That's the math. So you've got the load, which is the weight of the thing, pushing down, the force of the mass. And then you got the spring and the damper. And those become negatives because they're pushing against the load. And then you get it all to a point where it's the load in terms of X. Okay. Like front forks. Yes. So they're using a mountain bike suspension system as a ways of illustrating. Yeah. We have it as 5 kilos. And see how we got to go higher in the damping. Whereas a lower spring constant requires less damping. Yeah. So if we had mass, stiffness, and damping. and we had a function of update updates. What did they call it here? Update spring damper. That's right. Which we can probably just call it update spring. This here, I don't think I want to do that. Let's have a look at audio stream. We have nothing that needs to be bound. Object save type. Interesting. So under here, we probably want an obj save type as well, so that we can actually save this out as like a. I don't think I will need it because it's going to be some like an exported value on each of my rigid bodies that I want to be interactable. But we have the audio stream. Where's the variable? Where's the stream variable? The bind methods. There's nothing under here that. Because that's audio stream playback, not necessarily audio stream. Again, that's just binding methods. Because what I'm looking for, if you go into Godot, you go audio stream. It's audio stream player. That's what I want. Not audio stream. It sets up a set stream and a get stream. I don't see any variable. For the stream itself. There's a mixed target. There's the audio stream player internal. That's the compat. Where's the audio stream player bind? Bind methods in here. Okay, there we go. Add property. So we do something similar. So we don't need all of this. So if we go to get stream and set stream, internal set stream. So the internal is this audio stream player internal. And that's what holds the reference to the stream. Okay, so we don't need that for our thing, but we will need to set up. So for instance, those can be private. And then we can have public here. Float get mass. Then we need to do the same thing. But for this, damping. Amplitude, not amplitude. I don't know if I'll need all of this. I assume I will, because I can't see how the math would work without half of the variables. And initial displacement. So yeah, I wouldn't create this. I wouldn't create this for the rigid body that we're grabbing. What I would do is the player would create this when the player grabs something. And then this would calculate and tell the thing the player's grabbed how it needs to update. Because we need to know initial displacement and initial velocity. Initial velocity will be whatever the player's velocity is, basically. And initial displacement will be whatever the distance or whatever from the player's hand is. What's going to be very interesting with that is making sure that when we grab something, so if the player wants to grab a handle, we need to make sure that that's within range of the arm. Interesting. But if the player was picking something up, then it's just going to be, yeah, that thing moves to the hand. Whatever. I could make a pickup animation though. No, because if I make a pickup animation, then yeah, that doesn't really work. Player's hand moves to the item that they want to pick up. When it gets there, it's reparented to the hand. And it just follows wherever the hand goes, so it doesn't need a spring. All right. I'm thinking about things down the track, like future things. I need to stop that. I don't want to think about things down the track if I don't need to. So when update spring happens, it's going to do that stuff. Not going to worry about that yet. Pop into here. Yeah, I'm going to need the bind methods stuff, aren't I? It's a protected, yeah. Um, it's a void. That'll set up those. Then we also need those. Set mass. You do that for everything. Stiff. Sorry, that's a void. Whoops. Now we do a float. Where we get it. Just like your mother, getting the stiffness. It had to be said. Had to be said. Your mama jokes, count me in, please. Of course, the footlong wants to get in on your mama jokes. Get the force amplitude. Let's see what else we got. White crime. That's a good one. The driving frequency now. We need to get that. You might be wondering, why am I doing it here instead of in GD script? Why not? Why not do this in C++? It's just some math and such. It doesn't... We don't need to interpret it at runtime. We just need to run the calculation. That's it. Now we need the initial velocity and displacement. All right, so under here, what do we need to do? I know we need to add property. We do a property info, and the setter would be set mass, get mass. I'll figure out property info in a minute. How do we do the bind? That's it. Class DB. There's that. Oh. We bind the method. The method name is set mass. D method set stream string. Ah, I see. Like such. Let me copy that, change this to get. We get rid of you. There we go. And what was stiffness and damping? Know what I could have done? What you do? Could replace damping with amplitude. I guess we could go like Initial velocity. Huh. Why did that not work? Guessed a game doing 3 guesses. When you get it first guess, let me know. Why is that not? Huh. Force amplitude and driving frequency. Very strange. I see what it's doing. Very odd that it's not replacing within the block that's selected. Maya, g'day, you g'dunts. How the flippity fleck are ya? I almost said a word that would have been bad. How goes the GBA emulator? I saw you running tests earlier. I saw they all passed. So, well done. I'm dealing with mass spring dampers today for interactions and physics and stuff in my game. Yeah. Are you family friendly now? Heck no. But I want people that raid in to not immediately be scared off by me saying fuck. Working on the CPU interrupts right now. Nice. Still us do. Have actual graphics and stuff. Awesome. Awesome. Actual graphics. Fantastic. And I have no coffee now. Luckily, he's not in the UK right now. Here's the thing, Footlong. Australia has laws that are actually worse than that. For instance, if I was to put up an image of people from the Nazi Party with their uniforms and such, if someone in Australia saw that on my stream and felt threatened, if they felt threatened just because I had the image up, even if I was saying that those people are bad and they should be punished and whatnot, if they see the image and they go, I feel threatened, they can get the police to come to me and be like, they felt threatened by some imagery that you had on your stream. And then there's a whole investigation that happens. I'm calling them now. You messed me up as a child. Isn't that a little too sensitive? Yes. What did you tune into? Oh, they were just What if I feel threatened by you calling them a good dunt? I mean, you could probably still call the cops on that too. Like, yeah, that law was passed about 3 months ago, and within a week of that law being passed, there was a cafe in Canberra, which is Australia's capital city, which was called the Dissent Cafe, and they had photos of like they had photos of what Putin and Trump and all this stuff in Nazi outfits. And they had the police called on them after this law was passed. And they were forced to, like, the art was confiscated and stuff like that. It was like, are you serious? I once fart, but it was a shart. Ah, you pushed too hard. Yep. 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 That's the risk you take when you do that. Yeah. Yeah. More professional chatting at 100 messages now. Please click here to resubscribe. I'm letting that through. I'm letting that through. So at force amplitude, I think it's initial velocity and displacement to the last two we have left. But yeah, enough about that. Interesting, it got auto modded for you. It didn't for me. So auto mod learns based on how you've moderated things in the past. So it's based on your stream's moderation stuff. That message there is very much a possible. It's like a possible spam advertisement message. So AutoMod goes, this seems like someone that could be trying to scam people and get them to go somewhere to spend money. Yeah. Finds professional chatters and nukes them. Exactly. We don't want professional chatters here. We want people that don't know how to chat. Me, a scammer? I mean, it's in the name. Cosmosis T. I don't know about you, but that spells scammer to me. As my name spells scammer. Easy. People that don't know how to read. Brett Deloyer, a denial corporation. What do you think that means? That's good. That's good. Close. It's Brett Delauter, a dental association. The guy's a dentist. It spells pre 2010s. Most people got names like you. Such springy head tonight, I know. I got a new spring installed. It doesn't bobble, but you know. My email is my actual name. Jesus. So your email address is Lord Bucketface, son of Count Binface, nephew of Lord Buckethead. Outgrew Force. God, a Hotmail account. It's been a while. Oh, that has been a while since I've seen a Hotmail address. um, I must unsee. I'm confused. Which part of that is your first name? Out is the first name. Yep. What's the difference between a bad hunter and a constipated owl? A bad hunter can shoot but can't hit. A constipated owl can hoot but can't. Random seat allocation gave me window seats on all my flights. Nice. Nice. Personally, I hate that. What's the difference between a pickpocket or a pocket snatcher's watches? Oh boy. I love windows because I can control my bladder. I prefer to use like all of the flights I go on, Cam, are like 8 hours minimum. A minimum 8 hours. Now, it doesn't matter how well you can control your bladder. If you're not going to the bathroom in over an 8-hour time frame, you're not hydrated enough, which is worse. So I would rather have. This is what I do, Cam. I go in the middle. I go in the middle row. And I take an aisle seat. Because that way, if I have a couple, like if there's a couple that gets sat next to me, chances are the person in the middle is going to get their partner to move out of the way so they can go to the bathroom. I love how Twitch censored is the and not outgrew. Poop eventually turns into muscle. What's the difference between a brothel and a circus? Actually, I had an idea for a robot joke yesterday. What was it? Oh my god, it was last night as I was going to bed, so I didn't write it down anywhere. Oh my god, I knew this would happen. I knew I should have written it down. I knew I should have written it down. What up, Agashi? Scared me. I fell asleep while I was on my stream. Woke up. There's a floating head. Not just a floating head, but hands too. Yeah. When my hands aren't in screen, they could be coming for you. And my hands right now could be hunting someone. You don't know. You don't know where they are. I don't even know where they are. I'm doing well, thanks, Agashi. You should sleep. I agree. I agree. You should sleep. Carino thought if he got my flight cancelled, he wouldn't have to see me. I think that's what everyone hopes for. What are you doing, Cam? Your finger slipped twice. Still got a few hours before. That's me. Before that's me. Right. I've got. It's only 8:50 a.m. for me, so I got 12 hours until I go to bed. Right, I'm going to bed. Good night, Cam. Have a good sleep. 6 hours till I need to be awake again. We'll just stay awake. Why not? It's 4:20 a.m. for me. That's like an hour before I wake up in the mornings. Hour and a half. Cam is a cameraman. Yeah. Nah, because long flights. You can sleep on the flight, Cam. Time when you go to sleep, so you sleep on the plane and you wake up on the plane at a reasonable time, but based on where you're landing. So if you're gonna land at like 10 a.m. in your destination, you sleep on the plane until like 3 hours before you land. Because that way, it's like you've woken up at 7 a.m. in your destination and you don't have jet lag. I land at 7 p.m. at my destination. Well, don't sleep on the plane. Or if you do, make sure you wake up 12 hours before it lands. all I'm hearing, Cam, is all I'm hearing is problems. I'm not hearing you provide any solutions. All right, all right. You're a very problem focused person. We need solution focused people here, all right? What other property hints do we have here? Ow. Nice property hint nuns. The thing that we should go with. Hint string. If the plane is bound for an emergency landing, just ask the cabin crew if they have tried rebooting. We seem to be having some problems with our engines. Have you tried turning them off and on again? See you all when I'm in the land of the free. New Zealand. Cam's coming to New Zealand. Jesus Christ. The land of the free. Property usage. I think we just do default, don't we? That one line has now denied me entry. Nah. It's not like you're going to somewhere in the Middle East. Calm down. They would just be watching you, that's all. It's pretty much the procedure for a lot of airplane components. What's in the land of the free, brave democracy such that one goes there voluntarily? So Cam has a lady friend in the US of A that he continues to say is just a friend. Yep. No idea if that's where he's actually going this time, though. No idea if that's what it's actually if that's what the trip is for this time. Who he shared a cabin with. Exactly. Then he's going to Boston for Vino. How does that change what we were talking about? What if Cavino is the lady friend? That would explain why Cam's having such a tough time. Initial velocity. Initial displacement. Okay. I don't think I need to do that. Then we also need a good question, actually. I want to keep my stuff in line with what we got going on here. Yeah, this place. Yeah, cool. All right. That's not going to work. Um, Wait, I already have that. I don't. No, we'll look into that after the ad break. For now, let's just do some words. Ugh, do some relaxing. Rant. Rant away. Use the ad as a time for you to rant. Burn. Runt. Burnt. Nice, nice. Turban. Or you may be censored. Why? Barn is a perfectly fine word. God, if I can spell. A brat. Hmm. Bran. Yep. 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 Aunt. Of course, aunt. How could we forget that? A butt? A butt? I don't even know what the hell that is. I need to get rid of that Nightbot message for Stream Tunes to be close to something. No. I feel that G is fake, but I'm probably wrong. It's probably the Y or the P. If we go pure, P is fake. P is fake. Um, um, sure. How do you spell guys? I think that's got a Y. I think it's got an I in it. Um, I wonder if that'll be a word. P is fake. Sorry. Surgery. Oh, we still haven't made it. Well done to those that tried. To those that didn't try. What the fuck? What's your problem? How dare you? We need vector 3, mass spring damper, update spring. This needs to return. We can do that. In there is where we need the calculation to happen so that we know where it is. I would need to pass in the delta to it. The reason why I would need to pass the delta into it is because it's going to be based on the player. So that would be needed. Every physics frame, we call that passing in delta. And that updates the spring based on where the player is and the thing they're holding. So, how do we put this into our code? I guess this here could also take a vector 3 position. And we just update that vector 3 and return it out. So we do a calculation on that vector 3, or we do a calculation where that vector 3 is the current position, update it based on all of these values, and return it back out, and then the player can set that rigid body. Is that what we're doing with this? No, I think we want this to actually be applied to the rigid body we're grabbing. Because if we do it that way, then as the rigid body, like we can have the rigid body attached to other things as well. You know, so perhaps there's something you need to slide open, but you can't do it until you deal with something on the other side of it that's like locking it in place, sort of thing. So there's like a chain or something that's locked it there. And you need to like, you know, do something with that first. So then you end up with two springs counteracting each other: the spring of the chain locking it in place, and the spring of the the player grabbing it, trying to open it. Maybe. Maybe. I do want this to be a game, like on the object that we're grabbing, though. That pulls it towards. Hmm. So we'd want our damping ratio to be 1. Mass, spring constant, damping. We divide both sides by C. Get that on C. Is that. Then multiply both sides. No, then divide both sides by that. We would get C is that divided by U. Is that right? So if we wanted that to be 1, just be C equals that. That doesn't sound right. There's something wrong with my thinking on that. Something wrong with my logic there. No, that's right. We'd multiply both sides by this. Because if we multiply both sides by that, we would have that multiplied by this equals C. Yeah. But then it still works out. Like if we want the ratio to be 1, C would still equal that. Yeah. I could probably set up some functions. Like set up a function and have like a few different enums. Have like 5 enums of like weak like weak, medium, strong, and then like two in between, like and then whenever you set those, and then when we create the mass spring damper, it basically sets the ratio to like 0.2 for weak, 0.65 for mid, 1 for strong, Yeah, weak, easy, medium, strong gorilla type thing. Exactly, condition zero. Exactly. And then we just use those enums to basically determine what the damping ratio is, which will tell us, or to basically determine what the damping is. So that way we don't have to keep setting the damping. We just set what the spring constant is, like what the stiffness is, and what the mass is. And then we can calculate the damping based on the enum. And then that gives us 5 different strengths of spring. The enums aren't for stiffness, okay? Okay. And it's purely for me to build the spring physics, so it doesn't need to be Guna at all. All right? I do like that idea though. I do like that idea. So under here, we can have an enum of spring strength. That can be weak. It's always wise to extrapolate values into representations. This is true. This is true. Um, um, I don't want to end with exit condition 1. I don't want to have easy, because easy I don't feel represents a strength. Um, what up, K-Cog? How you doing? G'day, you get done. I mean, we could even have like, no. You're doing good. Good to hear. How granular do you want your enums? We only need 5. We only need 5. I guess we can go like weakest, weak, medium, strong, strongest. We can just do that. Yeah. Weakest, weak, strong, stronger. But weakest, weak, medium, strong, strongest. And down here, we can go. Oh, what was it? Oh my god. I've forgotten. Variant enumcast. That's what we want. That's right, isn't it? Yep. Soft, weak, medium, strong. And that could work too. What in the Gooner Town is exit condition 0 talking about? Don't want to worry. Don't ask, Vongo. Don't open. I'm not going to say that. Don't worry, Vongo. Don't worry. You'll learn when you're older. So we need avoid. Set spring strength. What up, Nal? How you doing? Hey, this stuff here. Lovely. Lovely stuff. You got banned from one of the biggest Minecraft servers. Well, that sucks for you. Look at that. 10 liters of wine. Or 4 liters of wine for $10. Like, come on. Equivalent to 5.3 glass bottles of wine. 10% alcohol volume. It's not good. Inside the box is that. Yeah. Wine boxes is very much what my mother swears to. Personally, I find wine to taste like wet sandpaper. You're not supposed to put sand in it. Alright, it looks like a lot of headaches in the morning. Oh, yeah. Yeah, it is. When I joined, why did you show me you were waiting for me? No. We're talking about. We've been having conversations long before you showed up, Niall. Come on. A set spring strength. And this we need to set up a strength as P strength. There we are. Bring strength. Did it to yourself. What do you mean? Oh, you were using hacks. Oh, you got banned. Your ban was something you did to yourself. These are, I think I'm using red switches. I think so. I've got. Where are they? Oh no, I'm using brown switches. These are my red switches. So. New hacks on Mr. Beast's Anarchy server because there it's allowed. I forgot to turn them off. Doesn't matter now. That's why you don't use hacks. Because you use hacks on one server and then you go to another server where they're not allowed, but you forget to turn them off, all of a sudden you get banned. It's like, whoops. It's just easier to not use them. This isn't going to be a float. And it'll have to be an int. Because that's what they all get set to. There we go. Switch. Strength. Weakest. Would then be damping of 0.2. And I can like tweak these values as we go, sort of thing. So at 1 is the strongest, 0.8. The damping I need to actually calculate though. That has a little bit of pushback, but not a lot. So let's say 7 for you. Because this is the ratio we need to calculate. Is the intent to keep them in floats for percentage? Or do you want them to represent Newton values? I'm going to calculate. So at the moment, I'm just kind of figuring out what I want the ratio to be. And then once I've figured out what I want the ratio to be, I can change this calculation here to determine what the dampening is based on the mass, the spring constant, all that kind of stuff. This is purely for me to kind of remember what it is, like what value I want. I drop this down to 5 for medium. I feel like medium might be better off it being 4. Maybe I do leave it at 5. And then weak would be 3. And then weakest can be like... Pop this one at 2.5. If I have medium at 5, that kind of makes sense. If I have strong at 7, I could... If I do it this way, there's no way for me to have like an overdamped. I think that might be good. So strongest is overdamped. Strong is close to being damp. Like underdamped, overdamped border. And then these ones go down into like various bumps. I did the same when I wrote Microsoft code. Gosh, the Windows code base is trash. Do you want it to be a linear increment? Not really. I want it to feel like there's difference. You know, so I don't want to go 2, 4, 6, 8, 1. Because if you have a look at 8, so if we had 8 as strong, that there compared to 6, there's not much of a difference there. There's no noticeable difference with that. Yeah, so I don't see any point in having those two like that. Whereas if we have 0.9, which is that, and 0.5 is medium, you can see how there's a noticeable difference in the spring. That's what we need to do. So it's not really linear. Like this one here, I could even bump it up 2.5. So 0.9. 0.9 would basically be it goes into position and stops. Point like 1.25 is as it gets closer to the position, it slows down and it doesn't overshoot at all. Now, whereas this one does the same, but it's basically when it gets to position, like it has less slowdown. It moves faster to its point. So what I can do, I need to take this and I need to put this into a function. Just a private function, just something that it calls itself. We go calculate damping. So whenever we set the spring strength, whenever we set the mass, whenever we set the spring strength, the mass, or the stiffness, we want to calculate this. Or maybe not whenever we set it, like maybe inside the constructor. After we've set all of those variables, we can do like, calculate damping in there. Get rid of that. Move this down here. So damping needs to be damping ratio 0.1, damping ratio 0.25, damping ratio 0.5, overdamped. Go. And then down here, we can do damping equals the ratio multiplied by the square root of mass times stiffness. That will give us our damping. That will give us our C. Yep. Thank you very much. In real world examples, those desert racing buggies that just sit when dropped from a height in terms of damping of their springs is what strong is, while stronger slows them before they hit the ground, kinda. So yeah, we basically get the ratio. Actually, we're going to take that 17, pop it up here. Ratio. Change that to damping ratio. Why is that not... Whatever. Overdamped. I mean, yeah, but it's like... It would be good to just be able to do, like, you know, replace... Maybe that's what I was doing, because I was doing the percent at the start. Yeah, it's because I was doing the percent. I was doing that. Yep. God damn it. um... Can't win it all. It's true. That's true. All right, so that will give us 5 different levels of spring that we can use in our game. We don't have to worry about tweaking things and being like, oh, with this thing being this maths and having this spring constant, like this spring stiffness, what damping do I want? Let's test it by like adjusting this stuff. Like, no. Just be like, make the spring one of these and it'll calculate. Like, we'll calculate the ratio. We don't need damping or damping ratio to be accessible outside of it. Now we need to actually do the calculation. Could be fancy about it and have an increased dampening based on the mass of the item to have a coherent dampening over all objects. No. Because when we pick up an item, it doesn't matter what weight the item is. Doesn't matter what weight the item is. We would want the spring to be strong. So that way they pick up the item. As they do the pickup animation, the item gets parented under the hand and it has a strong spring that moves it into the hand. And then they walk around with it in their hand. If they grab onto a handle or a lever or something, that will be given this spring strength, but the hand will be on that lever or that handle when they grab it. So it's not going to be moving. And then when they do move, it moves the thing that they're holding. And it doesn't matter how heavy that thing is. We want it to remain in the hand. Want it to be very strong. When they're holding like something on a rope or something like that, then we would have more of a week. So you'd have like a bit of leeway in the rope, and they pull the rope, and then maybe it like slides along a rail or something, you know. So that would be like a weaker, you know, or perhaps we want, I don't know. There'll be use cases for that, but mostly what we're going to be using is these two. Yeah. Yeah, exactly. Exactly. Let's see. Yeah, like there'll be other stuff that we can use this stuff for. Like we can have like a spring pad or something where like the player jumps on a spring pad and like throws them, or we can use this for when there's like gravity puzzles. When the player changes the gravity, we have like a like weak spring that pulls the player up to the roof, sort of thing. And we rotate them as they're going up. And then when the player gets to the roof, they like bounce off or something. I don't know. Once you get to a level testing stage, I'm gonna be creating. Where are we? So we've got this. This is gut, which is Godot unit test. So we can set up test scenes and have it basically validate that things work the way that we expect them to. But I do also have like a test, like test interactions and stuff that we'll be setting up as well. The first thing we need to do though is we need to update the spring. So I need to update the position of the thing that we're applying this to. So the equation of motion is this. What are these two? Those x's. So negative kx. So x is the that's on time. So a is root squared x over or delta squared x over delta time. Is that right? Is that right? Because I need to know what do I have here? Um, I guess the thing that's throwing me is this stuff. It's the... Isn't that like the change in x over the change in time is v? So that's just x. But what is x itself? X is the degree of freedom each object has. But like, what does that relate to in terms of this stuff? I would assume that would be the damping. But the damping is C, which is that. Because X is changing over time. What am I putting in here? This is the part that trips me up. It's like, for our purposes, what are we actually considering here? I know it's over time. We've got our delta. Can't be our position, can it? Because that would require it to be a change in the position. But I don't see how that works. Checks where the physical object, like mass in a spring, is located at any given second. So it is the position. So it is the position, is what you're telling me, which would be a vector 3. But I do need to pass in delta. Because the delta is going to be our time. And the reason why I want to pass in delta is because if there's a physics frame that's missed for whatever reason, we want to make sure that that's ticked up. So we don't accidentally skip part of the calculation. I think there's more math. I think there's more math that needs to go into this than is listed here. I think there's a lot more. Yeah, but sorry. Yeah, we don't have perfect dampening though. We don't have perfect dampening. So I don't. I wouldn't worry about it. Condition 0. I wouldn't worry about it because it's not this stuff here that's confusing to me. It's how I'm getting that implemented in here. And there's going to be a whole bunch of other stuff that I need to do in here that isn't done here. Because this isn't specifically about an object move. Like it's not our use case. Yeah. So there's something like there's other stuff that I need to calculate that's not showing. Like how the fuck do you code this mass spring damper? That's the main problem. Because I know all the basic components of it. I just don't know how to translate that into code. Ads coming in. We can take a break for the ads. Let's see if we can do better at words this time. What do you think? That's the thing, though, condition 0. I don't want to just copy someone else's code. If I was going to do that, I can just go download a plugin or something. Yeah. Let's go download a extent, like an add-on that someone's already made. Eight, nice, nice. Yeah. There we go. Well done, Slatey. Let's see. Heat. Rater. We can perfect this one. So there's heat rear. Yep. Yep. Tear or tier. Tar. H-A, no, R-E-T-H, I don't know, Reth. T-H-A-R, the R. Let's see. Plots. Took it from you, Sammy. Ouch. Way to not be quick enough. Costly. I'll take cost. Yep, clot. Um, 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 costly. Colts. Yep, yep. Cloys. Why'd mine go before yours? Ah. Oh yeah, cyst, of course. Um, Collie. Noise. Crashing it. Crushing it. Not crashing it. We're not crashing it, we're crushing it. Level 7 on the next ads. Because, yeah, if I want to... Like, if I wanted the code... If I wanted the code, I could just go in here. And I could just read. I would just take their code and apply it. Do I need initial velocity? Maybe. The initial velocity would be the velocity of whatever it is they're grabbing at the time that they grab it. Yeah, it'd be valid for like a rope scenario. Yeah. Otherwise, it's just gonna be 0. Like picking something up off the ground, grabbing a lever and pulling it, that type of stuff would be all 0. Initial displacement, that's the distance in a direction. That's the difference between its position and the hand position. So, so I guess in here, I guess we would need initial position there. Hmm. But if I was going to do that, like, so this is all going to be related in terms of moving one object to from one position to another. So we have the initial position. This here would be returning its new position. So what I could do is actually change this to just position. And then I don't even need to pass in a position here. Because we're already tracking position.
I just saw a Twitch stream where it had a message above chat where it basically had a stream summary but from AI. I'm not sure why people can't just read the title.
Sounds worth it to me. That sounds worth the tokens. Yeah.
Or just look on screen. Like, are we lazy?
Well, I guess it depends. Like, if you stream for 8 hours and you start doing one thing, but then if you finish that thing and you move on to another thing, then you could obviously, like, you could ask, like, people, I don't think people generally care about what you have already done on stream. I think they're more interested in what you're currently doing on stream. So I don't think it really matters what you've already done. If someone wants to know if you've already done something, they can ask and you can just tell them. Yeah. Usually update the title or can see what's currently happening. Yeah. On mobile, I won't be seeing any stream titles for I keep the video feed on full screen. That's another issue. That is another issue on mobile. All right, so we need to adjust the position. So what's the X? Is the X the position? I think that's the part that's getting me, location plus speed. But all we have is the initial velocity. So I can change this to be velocity. Because I don't think we care about initial velocity outside of it starting its movement. Same with initial displacement. I don't think we care about that either. Like, we just care about the current displacement. Right? Do we have a new hint? You don't. Sammy has already won the secret word. The secret word was player. It was player. I'll turn that off for now. Yep. Parent object tied to the physics like whatever position. It would. But the thing is, the position of the object that this, like the position of the rigid body that we create this spring damper for, it will update. Like, it will recalculate what the new position is, return that back, and then the rigid body will go, all right, this is my new position. So all we need to do is when we create the spring damper because of an interaction by the player, we set the position at that point in time. And then after that, it's just updating based on the, like, we just update the position inside here, return that back, and then the next time we calculate it, we already have what the position is, so we return that back. I guess the only issue with that is if something else interacts with it. If something else interacts with this thing while we're trying to move it, I would need. I guess I would need to pass in position. So we don't need an initial position because we'll be constantly calling. Like, every time we call the calculation, we'll be like, hey, this is the. Which means we don't need position either. Um, and then we would just be updating. Right? So every time we call update spring, we say this is its position, this is the float. But I guess that's kind of why we need an initial position. We need an initial position so that we can start the calculation. Right? Because I can have an initial position. I could even have a position. But do I want to call that previous position? Because if we go previous position, up here, we're passing in the rigid body's current position. Because you see, now the thing that we need to account for condition is if the player grabs something, but there's something else acting on it, like if something comes along and hits the thing that the player's holding, its position would move. But if we don't factor in that, then the spring would just ignore it and would just immediately go back to where it was. Yeah, store new position instead, then overwrite the previous original unless there's a problem. I guess that's probably a better naming convention. If I just have this as position, and then up here we go new pos. But I don't think this takes into account I don't know, maybe it does. Multi. Like sometimes it'll be single axis, other times it'll be multiple axis. But I want it to just be multiple axis because if I have a lever, yes, the lever can only move on one axis locally. But if we have that lever rotated in global coordinates, then the axis
I love you.
is not actually on a single axis. It's on like a combination of the X and the Y or the X and the Z. Yeah. How you doing, Hilden? Unfortunately, we don't have any hot sauce today because I'm out of crackers and I don't have any until this afternoon. So um what up, Gran? How you doing? Playing RimWorld, Hilden. Nice. Now heading to bed. Well, I hope you have some good sleep. I hope you don't have nightmares about your RimWorld being destroyed. On a completely separate note, is your RimWorld accessible to us so that we can like jump in and play a bit while you sleep? um Nah, it's nightmares. It's nightmares. I'm sorry to say. Sorry to say, but it is nightmares. Um why am I making life harder for myself? I'm not. You're making it harder for yourself. I'm not the one pronouncing things incorrectly. You are. All right, so we've got our time, we've got our new position. I just segfolded from that. Good one, good. I thought that might throw a few people off. Um, hmm. When if I just search for damping, then that's only going to give me part of the equation, right? That's mass. Number of degrees of freedom of a mechanical system is the number of independent parameters required to completely specify its configuration or state. Okay. Characterize the extent. But like again, this like what am I putting in here for my degree of freedom? Like, is that position? Is it position over time? Is it new position minus position over delta? Like, what is it? Is it 7? Because of the number of things that we're going to be using for calculation? Like, what? Theoretical distance it would have moved. But aren't we doing this calculation to know how far it's moved? Like, could I not just say, all right, it's theoretically moved 1 centimeter? How do I know if that is correct? What up, Bucky? How you doing? Subtract the speed with dampening value until the movement speed hits 0. The dampened and the 100 dampened state. What? It's going, that's for sure. Exit condition is throwing out a bunch of words that I don't understand. I know what the words are, but I just don't understand them in that order. In 1 centimeter movement speed, you subtract the speed. But that's the thing, I thought this spring damper was supposed to use the mass, the spring strength, the stiffness, the amplitude, and the driving frequency, as well as the initial velocity and displacement, to calculate how fast the thing is moving and how much it has moved over time. Yeah. if I'm saying all of my springs move theoretically 10 centimeters, then what's the point? No, I don't see a reason why I would need to tell it. Like there's got to be something I need to calculate to give me X. Yeah. I'm an amateur C++ dev, just so you know, Live Free. I'm working on a puzzle game these days, Bucky. Puzzle game where all of our interactions are going to be physics interactions, but I cannot get my head around this spring mass damper math. It just doesn't make sense to me. Yeah. So thanks, so don't worry, no critiques from me. Fair enough. Oh, I'll put it to you this way, Exit. Well, thank you very much for the prime. You fantastic Gidun. Much appreciated. I'll put it to you this way, Exit. If the player is picking something up, that item's just laying on the ground, it has no movement. It has no velocity, it has no acceleration. The acceleration would need to be based on the player's movement. But if the player is standing still and they pick something up, then what do I need to calculate how fast the hand is moving and get an acceleration value from that? At which point I would say that's unrealistic. It's unrealistic to do that. Well, the object would need to be would need to be stuck to the hand in some way. I just realized I haven't turned off a mode only mode for kick. Whoops. Whoops. So the player grabs a handle. The player grabs a handle of something that needs to slide along its x axis, let's say. Yeah. The player moves backwards, then that's going to make that thing slide. Obviously, because the player is moving backwards. The player moves forwards, it makes it slide because the player is pushing forwards. Yeah. Like the objects aren't moving on their own. I know what my usual problem is that I don't sit long enough with the problem I encounter while coding. Seems like you do and talk it out. Good to see that. Hopefully I can learn from you in future streams. I'm just stubborn. Even if I don't understand something, I'm just gonna not understand it for days on end. But I also have the problem of I get frustrated when I don't understand something. So I'm just constantly frustrated for several days at a time because I don't understand something, but I can't let it go. No matter how frustrated I get. Do the objects maintain momentum after the player stops interacting with them? Yeah, they can. So if the player's holding something and they're moving that thing, and as the player lets go of it, that thing could still move. Yeah. If it's a lever, if they let go of it halfway through, that lever would go back to its original position. Yeah. Does it move forever? Does anything move forever? No. They have mass and gravity impacts them. And then there's like other factors that go into it. But we're not taking those into account. They would have a linear velocity that diminishes over time. But let's get rid of all. Yeah, under zero friction, if there was no gravity, if there was no wind resistance, all that kind of stuff, yes, they would move forever. But let's forget all of that. Okay? Let's step back. The linear speed change plus massive item. But that'll have to come from the player. But then we've got the problem of if the we're getting too far down the track. Let's pull it back. Okay. All we need right now, because we don't have anything working at the moment. Nothing works at the moment. If the player picks up an object, okay, we need that thing to move into the player's hand from where it is on the ground. So the player will, the hand will get in the general area of the item, but instead of having that item magically snap instantly into the hand, we'll have it move and linearly go there. We can use a basic mass spring for that, and that would then become the foundation for all of our other springs. You know, the player grabs something, it's in the hand, and then they move stuff. Use warping function instead of use physics calculation. That would mean that we're not implementing something that we can expand on for future use. All right. So I could go through all of this exit condition. I could program everything individually. But that's going to take me 15 years. The idea of using a mass spring damper and its logic is that we have something we can reuse over and over again. Yeah. In order to have a spring, the item needs some kind of acceleration to dampen. It does. And that's going to be the fact that it has a distance. It's displaced from where it should be. So the spring would be pulling it, and the dampening would be what gets it back into place, right? Like if we have a look here, the initial displacement. So the initial displacement is here, and the spring pulls it back, and the damping gets it into its position. That's what we're looking for. How you doing, Irad? We're trying IRAD, but I don't understand it well enough. So it's going to be the spring constant. The spring constant is what would be used to basically pull the thing towards the location. And the spring constant we can tweak. And the spring constant, which is the stiffness of the spring multiplied by the mass, that gives us our damping, because we multiply it by whatever the damping ratio we want is. Yeah. Or implement the spring. No, IRAD, that's what we're doing at the moment. That's why stream title, IRAD. Stream title. What up, Jotson? How you doing? General equation for an exponentially damped sinusoidal may be represented as that. Other important parameters to include frequency, the number of cycles per time unit, the time for the amplitude, the exponential amplitude envelope to decrease by a factor of 2. Feeling fantastic. Good to hear. How goes the bobbles? They go. They go. I've got a bug I need to fix this afternoon, but it's unrelated to the update I put out yesterday. So, yeah. How goes the mailroom? Undimensional characterization of the amount of dampening. Very good. We announced our release date is October 26th. Nice. Nice. Just in time for Halloween. I like it. In the Tiny Teams Festival, which started today, and seeing good initial results. Lovely. Lovely. because that's our damping ratio there. Yeah, all I'm trying to do right now is figure out how to implement a mass spring damper in code. That's accidentally solved 3-body problem. No, I'm not. I can't even solve a 1-body problem. I do know Python exit condition, but I'm not installing a Python interpreter or anything like that to. I don't do Python code because that requires me to install like a bunch of Python modules and such. So outside of Blender, I know I'm on Linux and I have it conditioned, but I don't touch it because it requires me to. Like I only let things that need it use it, like Blender and stuff like that. Outside of that, I don't touch it. It's not the math. Like, we've been over this. Like, it's what is my dampening? What is my, like, what's the starting point? It's like, do I just tell it that it's, and like, do I just say, all right, fine, you're moving at 500 meters a second? Do I do that and then just have it figure it out from there? Or do I use the stiffness of the spring, the mass, and like the amplitude and stuff to determine how fast it should be moving based on the strength of the spring? Because the spring wants to go to rest. But if the spring is stretched, that's obviously pulling it. Yeah. That'd be a gravity calculation then. If it was moving down towards the ground, sure. But the rigid bodies already have gravity being applied to them. I can look at this all day and not make any progress. So that's what we want. So the engine already has that stuff. The engine already has gravity. The engine already has like a default. Where is it? It's already got gravity. It's already got dampening that gets applied to stuff for linear velocity and angular velocity. It already has all of that stuff. I don't need to worry about programming all of that stuff. That already exists. a rigid body already has that stuff being applied to it. Speed of object be based on the player's interaction speed. Interaction speed doesn't quite make sense. It's really just the hand moving and potentially picking something up. Like, let's say this cup is what the player was picking up. The player goes to pick it up. We're not going to have the player's hand grab it and move away. No, the player's hand would come down, it would get to like there, and it would do like the pickup animation. And we would just have this go, like, move into place based on the spring. Yeah. And then that would work with other stuff down the track as well. When the player grabs a lever and move it, that lever moves with the player's hand without needing to calculate some random things that only apply in that situation. Like when they grab a handle to slide something, or like when they turn and stuff like that. It shifts it. Or if player was capable of telekinesis. Maybe in a different game that had that, sure. Yeah. Fear mass and spring. Well, I've already got like a mass for the object, a stiffness of the spring, a force amplitude, and a driving frequency. We've already got that stuff there. Yeah. C++ extension. Are you using GD extension? No, I'm not using GD extension. I'm just coding it directly into my custom Godot. Because it would basically be, for picking something up, it would be a strong spring. It'd be a strong spring that does that. Yeah. And then like there's the natural frequency. That I assume would be our driving frequency. Yeah. Magnetic force between the object and the hands at a set distance, which would be controlled by the mass of the object and spring value. So the lighter the item, the more springy it gets. Not necessarily. No. No. So as I said, like, it was probably an hour and a half ago that we covered it. It doesn't matter how heavy the object is. If the object's on the ground and the player picks it up, I just want it to have a 0.9 dampening ratio so that it moves quickly towards the player's hand. Yeah, regardless of how heavy it is. Yeah. We don't want it to overshoot or anything like that. We don't want the player to pick up something light and have it spring back and forth between the hand. Yeah, and eventually settle in the hand. Yeah, we just want it to move to the hand and just stay there. No springy bounce back and forth. Yeah. And then But that's the... Like, that constant number isn't going to apply to every situation. Yeah? Like, we've gone through multiple situations here. All, like, how am I incorporating that into this calculation so that I can reuse this for anything I want to put a spring on? And some springs won't need that constant value. What I'm going to do, I'm just going to use this. I'm just going to have an initial velocity passed in here. We'll just do that for now. But if that's 0, if we have initial velocity is 0, if we have initial velocity is 0, yeah, that needs to be a vector. That needs to be a float. Yeah. Oops. If that's 0, then that's going to be a problem. I guess I can do something in the code, like in the game, being like, if the linear velocity of the item is 0, then just give it an initial kick or something. Have a good one, exit. Yeah, I don't know. We're gonna ads coming in anyway. Something tells me I'm gonna kick the idea of physics interactions and just go with something else. Figure out a different way to implement puzzles or something. Seed. Tweens. Here's the thing, Irad. If I implement a tween, what's the calculation to determine how fast and how much bounce there should be and things like that? It still doesn't fix the problem. Damn it, I was just about to take that one. Okay, I think T is fake. Reduce. Got him. Deuce. Nah, T is fake. T is fake. I think we've lost this. Yeah, we lost. We lost. It was a good try. It was a good try. Let's try some word chain. All right. See, key. Lock. It wouldn't be key lock, would it? Surely it can't be key lock. I didn't think so. Key like. Key. I don't know. The hell is this? Key. Oh, key lime. Of course. Key lime. Lime green. Green. The heck is a key lime? You've never heard of a key lime? Green screen. Screen. Screen something. Something starting with D. Screen. Display? No. Screen D-O. Screen. I don't know. I don't know. What? Screen doodad. Screen door. Ah. Door something, something money. Door pocket, pocket money. Door. Door what? Starts with a P. Door. I don't know. Door. Oh, prize. Door prize. Prize money. Jesus Christ, that was terrible. That was terrible. Terrible. One more. One more, then we'll get back into it. All right. Flea M. Flea might? No, flea market. Yes. Yes, good work, Slatey. Market S. I don't understand the connection in this game. A door prize is like when there's an event going on, people that come through the door, they could win it. Like there's a door prize for when people come in. Yeah. Market sale. Market stall. Market site. Market share. It's not share. It's SQ. Market square. Market square. Everyone was wrong. Square R. Rectangle. That's right, a square rectangle. Technically, a square is a rectangle. Square road. Round. Rocket. I got no idea what this one is. Square Roomba. Square root. God damn. Root. Something starting with W. Weed. Wire. Weird. Wide. Walk. Wrist. Whistle. Root. W-O. Root word? What? What is a root word? Word something something party. Yes. The most entertaining of parties. A search party. You know, we're doing one more. We're doing one more, alright? I don't care. Traffic stop. Traffic jam. Jam packed. Packed. Light. Luggage. Lunch. Lunch. I like lunch. Packed lunch. Yep, nice. Nice live. Lunch. Break. Yep. Lunch break. Break something something guard. Starts with P. Post guard. Break post. Break post. No, not break post. Patrol. Break patrol. Patrol. No. Break poo. Break punch punch guard. No. No. Break. Break prison. No. No, that'd be prison break. Gotta be break something and then something guard starting with P. Break point. Oh, break point. Point guard. Nice. Nicely done, Slatey. Oh. Perfect game. Perfect. I love it. All right. So, game explains what a point guard is. It's basketball. Basketball or netball, actually. It's netball. Netball point guard. Maybe it is basketball. It's basketball. There you go. Yeah. The point guard. The point guard is the floor general. Oh yeah, also key lime. The key lime, also known as a West Indian lime, Mexican lime, or Egyptian lime, is a type of lime. I don't think I've ever said the word lime in such a short time frame in my life. That like as much. It's treated as a species of botanical classification, originated a natural hybrid between citrus whatever and citrus whatever. It's got a thinner rind and is smaller, seedier, and more acidic and aromatic than the regular lime that you would be know. Yeah. And you got like key lime pie. Yeah. You're learning so much today? Fair. They have primary ball control and is in charge of setting up the offensive in basketball. That's why they're called floor generals. All right, so if we have an initial velocity, that's going to give us our kick. Yeah. Footlong to Joey. Nice. Thank you very much. Fantastic done. Fantastic work, Footlong. Why don't you sketch it out on a drawing for the formula? Well, I've got the formula and stuff here. And it's not the formula that I have an issue with. It's how the hell do I write the code for it? Yeah. Go about the exact dampening you need to stop the object in the hand every time. I don't need to do that. Like, we've already got the dampening ratio. So the dampening ratio, I'm using that. So up here you can see we set a strength. The strength can be weakest, weak, medium, strong, strongest. And that sets a dampening strength. And then that's basically, like, what we do with that is we use that dampening ratio along with and multiply that by the square root of mass times stiffness, which is these two. And that will give us our dampening value. And our dampening value determines how much it bounces, like how much the spring bounces. Yeah. So at 0.9, which is a strong spring, okay, that goes exactly to its point. You can see that line there. It goes directly to that point. We also have 1.25. Want the object to get to the hand without wiggles. Correct. And that's what this is doing. So when we pick something up, it moves to the hand, but it doesn't overshoot, which is what a weaker damping does. A weaker damping effect causes that bounce back and forth, which we can use that for other aspects of puzzles and such. Yeah. Whereas 0.9 has it go straight to the hand, basically. Yeah. Goes straight to the hand. No bounce whatsoever. 1.25, which is our overdamp, that's our strongest spring. That moves towards the hand at a slower rate. Yeah. So it slows down faster. Whereas that one moves pretty quickly. What we're missing up here is how do we do this calculation factoring in the position, delta and such, like is this x here, is that the velocity over delta? Like, it's not enough to just have the dampening value, the spring constant, and the mass. I need to convert this into a vector 3 position based on delta. You know, we have an initial position. We will give it an initial velocity. But as this comment says, the fuck are we doing here? Like, what do we do with all of these values? Because the one thing here The one thing here is x. X is used, and that's the... What was that? That's the degree of freedom. But what's that? This is literally the kind of exercise I have to study, but I hate physics, so I can't help. Like, the last time I did any sort of math like this was a good 10 years ago. So I've forgotten everything on how to do this kind of math. You need to find the time in the formula. Well, that's the thing. Like, the time in the formula, this is... Like, where's the other thing that I had? There's this one here, which if we get past the shitty-ass Grammarly ad, because Grammarly fucking sucks. Just learn how to spell, for fuck's sake. So this here has x, which F of s, so the force of the spring, is the negative kx. Alright? Let's have a listen here. What was that? Force of the spring. So x is the displacement of the spring, which is this. That's where this value comes into it. So P, our x is our displacement, and that's going to be how far away it is from the hand. Oh, okay. Okay. So displacement is vector 3. Velocity is also a vector 3. That's so much sense. So much fucking sense. This is what I meant by we shouldn't need to calculate anything else. Like, we shouldn't need to give it... We shouldn't need to come up with, like, some random value. Yes, x is how far it is from its resting position. Yes. You're a vector 3. You're a vector 3. Where is the time? Not in F. The time is the delta. I don't think I need those anymore, actually. And I don't need that. We don't need the setters. We don't need the setters for those. Because those are going to be set through here. We have the initial displacement, velocity, and position. And then those are going to be updated each time. What we're trying to do, we didn't hit the start. I'm setting up something for our physics interactions. So when the player grabs something, it gets to the hand. But if the thing they've grabbed is like a lever or a handle or something, that handle has a strong spring to the hand. So as the player moves backwards, the handle stays in the hand and a force is applied to the thing that needs to slide. And if the player tries to move in a direction that that thing can't move, then the player is stuck because like their arm stretches, and once their arm is fully stretched, the player can't move back anymore until they let go. Yeah. Stuff like that. Let's give you the force. If you have the force, you may move the mass of an object via the force. Yeah. So now that we have that, so x is the displacement, which means up here, this here, v is the change in displacement over the change in time. So the new position is going to be what our displacement is. So our new displacement, which is going to be a vector 3 displacement change, will be displacement minus new position minus I need a target. See, here's where it becomes interesting because this doesn't have a reference to the player's hand. And I don't want to be parenting this underneath the player's hand. So as the player moves, the displacement changes, and so do I want the spring to be on the player? So I could do that. Displacement change would be displacement minus dis. Or do we go target? Is the spring the arm or the connection between the hand and the object? The connection between the hand and the object. Because I think this here, when it doesn't update spring damper, it passes in a target, the updated target position of the spring damper. So we can actually have vector 3 init targets. Because we need to know where we're going to. I am purposefully not looking at the code that this thing does. I was kind of using its overview as a, oh, that's, yeah, I don't need the initial dampening or frequency though, I don't think. I think I can probably have those as just constants, maybe. Maybe. The change in displacement would be displacement minus target minus position. So we have the new displacement. So that way, if the target moves, the displacement is updated as well. If the target doesn't move, we still update the displacement, but it's just based on the same target position as the previous frame. That's our displacement change. That's u. And we've already got our time. So we can have our vector 3 of b. B in this instance is our dampening constant, I believe. Because our force damper is the negative BV. And V is the displacement over time. So our spring or our spring force is negative stiffness, which is our spring constant, multiplied by the displacement change. Is that right? Is that if there's anyone in chat that's implemented this stuff before or knows what they're talking about, and you see me doing something stupid, please don't sit there and just laugh. Okay, please correct me. And this would be our damper force, which would be the negative driving force No, the negative damping multiplied by displacement change over delta. Is that right? The change in displacement over the change in time, which delta is our change in time, and the displacement change is our difference between previous and new display. I don't know. We're going to see what happens. Now, what's that A? We have mass times first position and second position. First position is displacement change over delta. Second position, x and dx aren't the same. Correct. X is our displacement. So x is our displacement, or our displacement change. So yeah, x is our constant spring force, which is the stiffness, multiplied by our change in displacement. Now that's just our change in displacement, irrelevant of time. Okay, that's irrelevant of time. It's just how much our displacement's changed. Down here is where we have the displacement change in terms of time. X is displacement. First position is displacement change in terms of time. Second position is, what's d squared x? It's going to be something. X and dx seem the same to me in your code. No. This here, so displacement change is what our previous displacement was. It's the difference between our previous displacement and our current displacement. That's how much our displacement has changed. So it was displaced -1 on the y. It's now displaced -0.5 on the y. Right? And down here, we have that displacement change divided by delta. So that value there is very different to just displacement. Now it's probably there's probably a different thing I need to do, but as of right now, I'm not too worried. Like it might be that these two need to be, well, it can't be displacement. Can't be displacement because that was our previous displacement. Yeah. K is the spring stiffness. What's the D2 though? So this d squared here, how am I factoring that in here? Because it's not going to be displacement change squared divided by delta. Now, delta x, is it delta times x and delta times time? No, that wouldn't be right. There's the difference in x over the difference in time, the difference squared multiplied by x. That does make sense. Something's wrong. That doesn't make sense. Because it's the acceleration we need to calculate now. What do you mean displacement change equals dx? Kesame, what do you mean? Because displacement is just the change between, like, the displacement change is what our displacement was, and like the difference between what our displacement was and what our displacement is. So that difference could be, negative 0.3, because we've gone from 1 meter displaced to 0.7 meters displaced. Yeah. So we'd have a 0.3 displacement change, and then we put that over delta, which would give us the change in displacement relative to how long it has been since the last update. So listening to this, I know you can't hear it. Right there. So the force of the spring is the negative spring constant times the displacement of the spring. So I guess a better term for this wouldn't be displacement change. It would be... What do we need to do? If you pull the string, then release it a bit. Displacement change becomes positive, but spring force is still negative. You got to remember, Kasame, like, this is like, we're only implementing this to pull stuff to the hand. Yeah? That's all we're implementing this for. We're not implementing it to launch stuff away from the hand. Yeah. Like that's where dampening comes into it and stuff too. Like you get down here. Like that's our end point down there. We need to calculate everything in between it first. So you tell me, Kesame, what would you do? What would your calculations in here be? Because if there's something I'm not getting, I'm gonna need you to tell me what it is. Actually, has Gamer redeemed late? I don't think Gamer's redeemed late yet. So we've got our updated target. That could be the same. It could have changed. A new displacement. Don't try and write the code out or anything, Kasame. Just it. Yeah. Because we have the new displacement. Now I need, what was it? Spring force is the negative stiffness multiplied by our displacement. Is that right? So x is displacement. X is displacement. It's how, like, what the difference between its position and its target position is. So that's the displacement. And then, so that would be the spring force, the negative stiffness multiplied by displacement. And then what we would need for first pos, which is this one here. So first pos, second pos. Uh, um, so we'd have to do what? Displacement minus new displacement over delta. Because first position is the difference in, like, the change in displacement by the over the change in time, right? Dt is delta time, yeah, which is delta. Like it's literally a variable called delta, like. But yeah, so that's dx. Like, you've got to look at this entire thing here, not just the numerator. All right, you got to look at not just the numerator, but the fact that there's a denominator too. So you got dx over dt. Okay, that's what we're looking at right there. So first position, which is this x dot, is that. And then vector 3, second pos, is displacement squared multiplied or minus. And that needs to be. That doesn't seem right. I know they're not, but so go back here. Listen to how it's explained. First and second derivatives. First and second derivatives of positions. So they're the first and second derivatives of the position with respect to time. So this here, x dot, for example, we'll call it x dot. Okay. Being time before and after delta time. Being the time before and after the delta time. T0 and T1 are the time before and after delta time. So what would you put for x dot? It's just displacement minus new displacement over delta. And then our x dot dot, our x double dot, I would put that test. What? I would put that, yes. So what's the x double dot? Is it just the displacement minus new displacement squared? Then put that over 2. Put that over delta squared, which doesn't make sense to me, but because it's the second derivative. Like, how are we getting the second derivative? We're past we're past dx. We don't care about dx anymore, I reckon. We can't calculate the velocity without having dx in the first place. So we know we had a displacement. We had a displacement. We now have a new displacement. And we're using the difference between those two over delta to give us the velocity. All right? Forces mass times 0. You're not looking at what we're trying to do here. Like, IRAD, you're not looking at what we're trying to do. We're trying to implement this here. All right? We're not multiplying mass times acceleration to give us a force. All right? That's something that's going on up here. Yeah. The mass gets taken into effect down here. All right? Like needs to take a step back and figure out this part first. Figure out this part here. All right? We are trying to, Revival. We are trying to. But we're having trouble with understanding the physics. We're stuck on this part. The second derivative. How do you calculate the second derivative in coding? Programming second derivative. I have no idea if that's how you spell it. It's probably not. Second order derivatives. There we go. How the fuck am I programming it? D over dx multiplied by dy on dx. And the first derivative is dy on dx. It is IRAD, but you can't just calculate that magically. You need a bunch of other numbers first. Yeah. So we've already got x dot, which is our first derivative. Now second derivative, which is, we've already got our first derivative, which is going to be, so I assume this would be displacement over delta. No, that doesn't seem right. We're doing something wrong here. We're doing something wrong. Our second and first derivatives are wrong. Well, we're implementing this, Kesame. We're implementing spring damper physics, which requires us to have an acceleration to go into this equation. We're going to pause there because obviously we're just going around in circles at the moment. We're going around in circles and I need a break, otherwise I'm going to just get annoyed. Word chain. Let's see, visit the archive. This one here, we're doing this one. We're doing this one. All right, so forward. No. What? Straight farm. Straight fake. Straight face. What's the fuck is straight face? What is straight face? Face. No idea. A horse. No idea. Face value. Yep. That's a good one. Value point. I think proposition might be a bit too much. Too many letters. Rat race. Something rat and value something. Value poisoning. Value pack rat. Right. I see how it is. All right. Science fair. Fair. World. No. Fairway. Nah. Fair weight. I don't know. Fair wear. Weather? Fair weather. Weather. Table manners. Card table. Weather something something card. Race card. Red card? No. Weather rep card. Report. Of course. Oh my god. Second sun. Second W. Keychain. Something key. Second wind. Yes. Yes. I think I finally got the game. Wind. Something. Sock. Wind sock. Wind store. That's how I get my wind. I go to the wind store. Wind sound, wind siren, wind sail. Ah, fucking damn it. Wind. Oh, sock. Wind sock. It was wind sock. What the hell is a wind sock? Sock something starting with P. I don't know. Sock power.
Good night, I love you.
Sock puddle. Good night, Sammy. Sock puppet. Hey, puppet. Mobile. Puppet. Manager. Master key. Yep. Very nice. Very nice. It's a fun little game. It's a fun little game, that. I have no vocabulary, but I may have found the solution to the spring problem. What is it? I didn't believe it was sock. Like, seriously. A wind sock. It is that. That's a wind sock. Why isn't it a wind tube? I don't know about you, but if I had a sock with a giant hole on either end, that's not a good sock. That's a bad sock. That's a terrible sock. Maybe we can do the same before by calculating 2 speed and deriving by delta. It's a wind leg warmer. Variation of speed over time is acceleration. So you're saying we do that, then we do 2 speed. Because this would be velocity. This would be acceleration. So you're saying it's 2 times velocity over delta. Fun fact, last week I was on the bridge between Sweden and Denmark by car with an empty box trailer attached. The windsock was straight. The wind was so freaking strong. In the middle of the bridge, it flipped the damn trailer on the highway. I'd call it emergency tow truck. Speed at T0 minus speed at T delta. So it would be our previous velocity minus our current velocity over delta. Is that what you're saying? Okay. So if we have that, then how do we factor this into the position and such? Because we still need to factor in the force amplitude and the driving frequency. Which, where are they put in here? I don't think they are. And how does that become s squared? Is that because it's speed? Oh, x, yeah, because your speed. Yep. Yeah. So it would then be just so that I can get this right, we would have mass multiplied by new velocity squared times the new displacement plus the damping multiplied by new velocity. Actually, I can get rid of new displacement from there. Plus our spring force, which means I can actually get rid of this. Because that's just going to be stiffness. Then we have all of that multiplied by our new displacement. And that becomes our force. And if that's our force, I'm assuming that would be our current position minus the force. Where's the big X? The same as the X everywhere else. I've just written it slightly differently. It's like it's still just X. They're just substituting. So they're saying like X is displacement. Like this X here. And this one here, the negative B times velocity, is speed displacement, like the dampening thing multiplied by speed displacement stuff. And then this one over here, the second displacement, is the mass times speed squared displacement thingamajig. Yeah. We can go back, be like, yeah. The beginning of the function is going to be displacement. No. Isn't that double multiply? Or is C++ using that? Hang on. Hang on. So there is no symbol. Okay. So I have to MathPal. There we go. What are you complaining about now? It's because it. Yeah. Of course, new velocity is vector 3. So how am I doing that? Because that's going to require... I guess I can just do... It's just that. Same goddamn thing. And of course we can't have stiffness just being added onto it, because I guess that can be going to need a vector 3 1. How can I access that? I don't think I can. Um, okay, so there is no. Ah, there is. 1.0f, 1.0f, 1.0f. Then multiply that by stiffness. And this could be stiffness Beck. There we go. But we haven't factored into account acceleration, which would have been that. Right? Right? Something like that. So we're substituting these x dots there. Like, stay with the line before big X. Like, then all we're doing is substituting. So we've got X, which is the displacement, the new displacement. The X dot, which is velocity. So B times new velocity. And M second derivative, which is the mass times acceleration. You see, you're saying x dot dot is acceleration, which is speed squared times distance, which is different to this. I know, I'm saying what IRAD said. So IRAD saying that x dot dot, which is acceleration, would be this squared. But would be speed squared. Because having velocity minus new velocity over delta, that is our acceleration, yeah. That would be our acceleration because yeah. If you're accelerating at 1 kilometer a second, then over 1 second, this difference here, like if you add up all of that over 1 second, it would be 1 kilometer. Something like that. Something like that. It's been. I think I need to just. I think I just need to just like spend some time redoing some fucking math, some high school math again. All the math that I haven't looked at for a decade plus. So is updating the position correct? So if we're subtracting the force, see, my main problem with this is we haven't done anything with our force amplitude or our driving frequency. I suppose that should probably be plus, right? Displacement is a difference between two positions. So if the player's at global 0 and something is over at x01, also like 201, then it's displaced by 201. Like a vector 3 where the x is 2, y is 0, z is 1. Yeah. Expression of position, no force, not velocity. Yeah. Correct. Well, how would you do it, Kasame? How would you do it? We need to stop. I think we need to stop with the no, I wouldn't do that, and then not progressing from there. We just need to go straight to the actually it would probably be better to do it this way. We need to skip the 3 steps before that. If someone has a problem with something I'm doing, I don't care what the problem is, just correct me. Because correcting me, I will know what the problem is. So, if you wouldn't do position plus force, how would you do it? Thing is, I don't have a full solution. That's fine. I don't have any sort of solution. I don't even have a part of the solution. I I don't care, Kasame, just what would you do? Like, I know that it's calculating force because I've literally got something here that says the force equals that. So, honestly, I'm at the point where I'm just thinking I'm going to get rid of all of the physics interaction stuff and just come up with something different. Just come up with something completely different and just fuck it all off. Because this feels like it's more trouble than it's worth. Put position on the left and force on the right of the equation. I've got like force being added to position, like that there's left, that there's right. Right? On the equation before. Why? Do you mean doing... Are you saying that? Because that doesn't look right. Because the new displacement, we don't want to be changing that. Like, the new displacement is going to be assigned to displacement. So the next time we come through, we can do this calculation again. We don't want to be changing new displacement because that's just the target minus position. So once we calculate the new position, then we can... Honestly, all of this seems wrong to me. For what we're trying to do, I feel all of this is wrong. You know what? We're getting nowhere. So let's have a look at how this does it. So this is a GD script implementation of a spring damper. Okay. So they have, for the constructor, the initial position of the spring, the initial velocity of the spring, the initial angular frequency of the spring, a float that determines the spring strength, the initial damping ratio of the spring, the initial delta time value. That's only if it's being done. Do not provide a value for this if you're updating inside. So that's only for physics stuff. And then the update is a target, the updated target position of the spring damper. This should be of the same type of the initial position. Delta, the current frame's delta time. And we pass this if you're not calling update in the fixed interval. The return value of this function is the updated position. However, you may wish to access the updated velocity of the spring damper after such a call and can do so with that. Fixed update. Yep, so you do it inside the physics process. Springs are intended to be instanced from code as an interpolation utility for node implementations. Right. Let's see. There's the position, the velocity. Now those would be vector 3s in our instance. Okay. We got the frequency. There's an update motion params. There's damp, which is same thing. Positive coefficient or position coefficient or position velocity coefficient. Velocity position coefficient. Velocity coefficient. I have no idea what the fuck those are. Fixed delta. So I don't think I'd have a fixed delta. So the init sets up those default values. Okay. How are they passing them in though? Calculate damped motion params. What? Z1E1 over 2ZB plus Z2E2 over 2ZB. What? What? ZA is the negative frequency multiplied by dampening. ZB is the frequency times square root of damp multiplied by damp minus 1.0. What? Z1 is ZA minus ZB. Z2 is ZA plus ZB. So that's just our two different positions, I guess. Our exponent 1 is Z1 times delta. Exponent 2 is Z2 times delta. The inverse 2ZB is 1 over 2 times ZB. Right. I think those are just intermediary steps to convert from current displacement to the new position. Then you got the omega zeta. Okay, I'll throw it in some fucking Greek too. So I know that zeta, we have a look. Where was it? We have a look at this. So zeta is our damping ratio. So that's our dampening ratio. Frequency multiplied by dampening. And then this here, the update spring damper. Old position is position minus target. Calc damped motion params. Calc damped motion params. And that's going to give us these here. Position is old position multiplied by that plus the old velocity multiplied by that plus target. What? What? I was thinking this might shed some light on it. This has just made it even more confusing. This has not helped at all. Let's have a look at this. This Ryan Jacquet's damped springs. Maybe this'll have something good. I think this was the thing that okay. Particular solution. So there's general solutions, there's particular solutions, there's... God damn. It's like something that explains the whole thing in writing. And 1 point and a point mass attached to the other end. At rest, the spring has length R. As the current length P deviates farther from R, will generate a force in the opposite direction. We can define this force as the value K is called the spring constant and controls how strong the spring is. Higher value of K will create a strong force. Sum of the displacement from the equilibrium position R. In order to make our lives easier, let's define the variable x to be the position relative to equilibrium and simplify the force equation. So R is the length and P is the current length. Okay. Let's just start with that. So if I do float force as... I guess that's something I haven't specified, is a max length. Okay, so if we set these up, my God, my typing today is horrid. Set max length. Do that. Voila. Okay. So we have our max length, which is R. Actually, no, that'll be our rest. Actually, our rest is 0. Our rest is 0. So our force is actually just going to be the current length negative stiffness multiplied by the current length, which would be target minus position length. Actually, I could do distance to target. So if it's a positive distance, our force needs to be negative to subtract that. If it's a negative distance, our force needs to be positive. That's why the negative is there, because if it's a negative distance, you multiply that by a negative, you get a positive. Yeah. So that's our force. As I said before, we really want to dampen harmonic motion. Useful exercise to learn how we derive formulas. Simple harmonic motion first. Also learned simple harmonic oscillator is not sufficient for the needs of simulated video game camera. Our goal is to find function xt that solves our position x based on time t. I don't recall my physics, that's the problem. Acceleration is the derivative of velocity, and velocity is the derivative of position. Refer to the position. Velocity, acceleration of our equilibrium relative position x as follows. X is position, velocity is the derivative of x, acceleration is the derivative of velocity. Okay. So we do already have our position. Our velocity we don't have we don't have different positions at this point in time. So acceleration induced by a force is inversely proportional to the mass. Massive rock's hard to push. There's also a law that gives us the equation force equals mass times acceleration, where is the mass attached to the spring. Earlier we said that force was equivalent to negative k times x. Due to the spring, we combine those force equations into one equality as follows. So mass times acceleration plus k. Plus that. Yeah. We're going to rearrange the equation and define a new variable w. We're going to find that w is the angular frequency of the spring, which is the driving frequency. K over mass. So if we have the angular frequency, I guess that's not the driving frequency. No, it would have to be the driving frequency. I'm very stumped by this. I'm super stumped by this. Like, what's the point of driving frequency and force amplitude? And is driving frequency different to angular frequency? Wait, is the driving frequency just the natural frequency? And this angular frequency is... Um, actually, sabotage is a good one. Um, I don't think I'm ever going to understand the math behind this. So if we go like motion as mass times, we don't have acceleration yet, so we can't calculate that. Because acceleration would be this part. Mass times acceleration plus or minus force. Because over here, it's a positive kx, but our force is a negative. So rather than having a negative, like rather than getting rid of that and just making it positive, we can just have a negative there. So that way this stays the same. And then this negative, when that's negative, will make it a positive. But when this is a positive, it'll become negative. So that should be okay. What up, Random? How you doing? Um, then we can get somehow to get the x. Well, we've already got the x. Like x is the current displacement, like the current length of the spring minus the resting length of the spring, which for us is just the length of the spring. Yeah. In fact, you can sit down for like 8 hours a day and return to the same code base. Really impressed. Do you have any tips? Honestly, is if you enjoy the thing that you're trying to make, if you really want to make that thing, it's easy. If you're finding yourself struggling to sit down and work on something for a couple of hours at a time, you may not enjoy the project that you're working on. So, like if I sat down and tried to do music creation for like if I tried to create music and tunes and stuff for like 5 hours, I'd go insane. I'd give up by the second hour. I know this because I've tried to do it. Because when it comes to creating music, I'm just not that interested in it. Yeah. um. So yeah, I'm an actual computational physicist and physics teacher. I might be able to help you stuck with something. Random. We want to implement a spring mass dampener. How? So the resting length of the spring would be 0. So the distance between the position and the target is the length of our spring. I'd prefer not to believe I don't enjoy my projects. May need some introspection then. I will also say this. If you're making a game on your own and you have to do the music, you have to do the artwork, you have to do the code, you have to do the animation, all this stuff, you probably won't enjoy all of that. You'll probably enjoy some parts more than others. You'll probably dislike certain aspects, like perhaps you don't like doing artwork, for example, stuff like that. If that's the case, you just have to push through it. You just have to force yourself to sit down and get it done, because that's the only way it's going to get done. Length of spring can be negative. So are you pulsing left and right of 0? That would depend. That would depend on our damping ratio. So over damped, no. It would just go towards that position. Add jail? Alright. Well, if you're in add jail, we'll just do another word change. You know what? We'll do a chess. We'll do a chess while you're in add jail. Ooh, wasted a move. Suffer. um, let's see. We can do that. Push these. I like how they keep doing this, because I just do that. Like wait for it. Hmm. Go there. Hmm. I have a plan here. Oh, motherfucker. I need to get rid of that. I need to get rid of you. Oh, do I need to piss you off? Sweet. Yeah, I've got no time. I'm timing out anyway, so it doesn't really matter. That's what I thought. Yeah. Yeah. Screwed up on the end there. Do compiler programming language. Oh, nice. That stuff's way too difficult. That's way too much for my brain to process. All right. So about some questions. Is your damper velocity based? Is your damper velocity based or mass based? Means you want your dampening
DuckDuckGo released
to...
anti-AI sunglasses called normal fin glasses. Lol.
Do you want your damping to increase with velocity, or do you just want a constant damping? So this is the kind of thing I want. So if it's a low damping ratio, then it kind of just goes over time. But if it's a high dampening ratio, then it's very much just like that's the kind of thing I want. So mass damper. Yeah, mass damper. Can you spring swing left and right of 0? Meaning the relaxed length of the spring is at x equals 0, and the spring extended is x greater than 0, and the spring compressed is x less than 0, or is it an extension spring? That'll be determined based on, yeah. Got the damper. What about question 2? So it can go past the relaxed length. So I assume that's what you mean. So it can, depending on our damper length, like depending on our damping ratio here. So these ones here would go, yeah, so like a 0.1 ratio would bounce more than our weak, which is a 0.25 ratio, which bounces more than our medium, which bounces more than our strong, and then our overdamped would just, yeah. And then the way we're calculating this, so the way we're calculating our damping before you go too far random, the way we're getting our damping value is we set what type of strength we want, what we want the damping ratio to be, and then we're actually calculating our damping constant based on the ratio multiplied by the square root of mass times stiffness, because the damping ratio is the damping constant divided by the square root of mass times stiffness. Or stiffness being spring constant. We also need to remember something could hit that, like the mass at the end of the spring, something could hit that and like move it, which is why we're passing the target in here. Also, like the player can move as well, causing the target to change and stuff. So yeah. All the damper is friction. What is Fn? The normal force. So that's mass times gravity. Is that what you're saying? M times G. So here's the thing, random. Here's the thing. We're not implementing this for a spring that we put stuff on, like goes down and up sort of thing. We're implementing it for player interaction, player physics interaction. So the player grabs something. We want the spring to be between the player's hand and the item that they're grabbing. So then when the player's hand moves, if they're holding onto a handle or a lever, the player hand moves, that thing comes with based on the spring strength. Okay, so I don't want gravity to be like I don't want an item to be like getting picked up by the player and it like falls because of gravity. Yeah. So it would be a float force or friction as the stiffness multiplied by mass multiplied by, what would it be? I guess that would be a vector 3, 0.0, negative 9.8, 0.0. Something like that. So that's going to end up being a vector 3. Because our gravity's... Or would I just have this as a float and just that? I guess that's the other thing, is I need to be able to get gravity. Could pass that in. Just number 10 is fine. But if I'm... So here's the thing, though. Like, if I'm going to have gravity change in my game, would I not want this to be the same as the gravity that the game is using? Or the gravity that's being exerted on that object at that point in time? Right, so what I'll do is up here, I'll go like a vector 3 gravity. So that way, when gravity changes and stuff, we can do that. So that's going to end up being a vector 3. All right. Just the magnitude. All right. We'll go float, then that would be length, right? The length of the vector 3 is the magnitude. Is that right? So we do that. Yep. Yep, so that's our friction. Yep. That's going to be stiffness multiplied by x. So what's x in this situation? Is that our displacement? Like, what's... Okay, so is that going to be our new displacement, or... Because we have an initial displacement. Like, we do set the initial displacement. but that's obviously a vector 3, which I guess I could change that to be. I guess I could change that to be a float. And then that would just be the length. That would just be the length of the position minus target. Right? But then if we have a new target coming in here, we would want to go new displacement would be target minus position length. Because I assume we need the difference between our old displacement and our new displacement to calculate velocity, right? But anyway, so we've got the spring force. It's done. Finally! Robin has a better goddamn game duel score than us. Finally! Freaking hell. Took your time with it. Some of the forces, mass sign acceleration of the whole system. Pushed my chat to finish it today. Nice. Nice. So that's acceleration of the lever that your player's hand is on is like this. Mass acceleration is the FF plus FS. So Ma is friction plus spring force. We're still stuck with the physics interactions, Robin. Random logic is taking me through and explaining the math of our spring stuff. So negative K. Negative KS. What the fuck was KS? The spring force is KS times X, which is our spring constant times displacement. So that would need to be a negative. And then what's KD? The displacement times mass times gravity, or the That's the first time I'm seeing K underscore D random. K underscore D is your dampening constant. So it's not stiffness, it's just damping. All right. The damping force is our damping times mass times the gravity length, and our spring force is negative stiffness times the displacement. So a mass times acceleration is friction plus spring force. Let's do some maths to simplify our life. What, that wasn't the simple part? Oh. Alright. How is that Hang on. So that's our acceleration. So our acceleration is negative stiffness divided by mass multiplied by displacement. And then we're adding the damping constant times gravity length. So that's our acceleration. And we already have our mass. We don't need that. Yeah, physics professor to figure this out. That random. That's what random is. AF minus AI is our change in acceleration. Where are you getting AF and AI from? Because we're passing in the delta too. Like, we do have the delta time between physics frames, and we haven't used that yet. A final minus A initial. We don't have an initial acceleration though. We have an initial velocity. So how are we doing AF minus AI if we're not? Now we finally have AF minus AI. We don't have that yet. We'll relate velocity and acceleration soon. So what do I do next? Because you've said that after this you said, so now we finally have AF minus AI, but we don't have those yet, right? I just want to make sure I'm not missing a step. I feel like I'm missing a step. I'm not? Alright, cool. I just wanted to make sure I'm not going insane. Okay, so XF and XI is our displacement final and displacement initial. So that's our displacement final, and we already have our displacement. Okay. Okay, what's this trick? Okay, yep. Acceleration is equivalent to a v times delta t. So velocity times delta t. What's our velocity? Which is our displacement minus new displacement. No, minus. Delta t is changed in time. Yeah. Yeah. TF minus TI. What the hell is TF and TI? Oh, time final, time initial. Well, we only have the time since the last frame. The time initial would be 0. Correct. Well, you assume that it will be constant. Physics frame rates are generally constant, but if anything happens that causes frames and physics rates to drop because of like hardware or something like that, the time will accumulate and yeah. If a physics frame is dropped, then it'll be twice as much, sort of thing. It'll be about 0.0166. About that. Correct. Correct. It's always that. So that's what I'm saying. Like acceleration is velocity over delta time, but we need velocity first. Like, so I feel like we're redoing parts. We've already got acceleration. the velocity, that, so acceleration final minus acceleration initial is velocity times delta time. We haven't calculated velocity yet. Velocity is that. We've already got that. That you've lost me. I know what we want random, but you've lost me through those steps because we've got our acceleration, which is this. You've said acceleration final minus acceleration initial is this. And then you've also said our velocity times delta is this. I'm lost. Because our velocity times time is our acceleration. All of it just comes back to this. Right? So, should I be storing certain parts of this in variables, or are you just going through different parts to explain the full process? Right. Right. So that was just explanation stuff. It was like there wasn't any expectation of me to like store any variables or anything. Right. Right. Do we need velocity? I assume we need velocity. We have an expected velocity. Wouldn't that be the actual velocity? Because we had a previous displacement, we've now got a new displacement. We're dividing that by time. Yep. Okay. Now we do already have a position. Yeah, if xi is the initial position. So the final is our acceleration plus initial position. Why would it be minus xi? When we move xi to the right hand side, wouldn't it be positive xi? Wouldn't we be adding x initial to that? All right, cool. So the negative spring stiffness, spring constant, negative spring constant stiffness divided by mass multiplied by the new displacement, which is incorrect now. Because that would actually be the velocity. Multiplied by velocity times delta minus our damping constant times gravity length. So we'd have all of that. Then we would add position. So I don't need any of that. So multiplied by a unit vector for the direction of motion. So we would want to go multiply that by our direction, which would be position direction to target. Let's do that. So our final position will be all of that added onto the initial position. So we're adding this onto our initial position. I'm going to break some of this out. I'm assuming that is our acceleration, velocity times delta is our acceleration. Okay. And then What would that be? That. Dampen would be dampening times gravity length. That's how much we're dampening by. Direction be direction to target. And I'll call it spring force. If I can type. Right. Yeah, divided by mass. So that seems a lot simpler than some of the other stuff we've seen. So if we have a look at this. So this here is an implementation based on this stuff. But if you have a look at theirs, they do all of this stuff with whatever position coefficient, position velocity coefficient, velocity position coefficient, velocity coefficient. And they start throwing in frequency and I have heard of Rust. I've heard of Rust. Come to share the word of the borrow checker. Yuck. Yuck. Why would you do that? Sounds disgusting. I don't want nobody checking what I borrow. So yeah, like random. What is this? Do you understand any of this? If you want it to actually move like a spring, you have to change directions of the limits and frequency. Is a nice way to do that. So that's to make it actually behave like a full oscillating spring over a long period of time. Like that. Well, like, so what I'm looking to do random is have this as foundation for something that I can expand later and have something that I can use for the player grabbing something and pulling it, or for the player pushing something, or for the player like maybe something falls down on a rope sort of thing. Yeah, maybe we've got two things that collide that like something that's pulling on something else. Like the player turns something and that causes something to like pull along. Short time duration bounciness. All right. So the only thing, like the only time it would need to be over like long durations and such is if it was like vehicle suspension. Right. And because I'm not doing that, like if I was gonna do a vehicle, if I was gonna do a vehicle in Godot, Godot has a vehicle body. Godot already has a vehicle body. And vehicle wheel. And vehicle wheel has suspension force and stuff. So I don't think I need to I don't need these springs to handle vehicles. So if we have that, we have this. Target desktop. I've completely forgotten. What's the build command? Kind of annoying problem with time varying forces. So you do need more complexity. Yeah. If I don't need to worry about it, I don't need to worry about it. Let's see, where's the compilation? Platforms Linux BSD. Yep. Yep, we're doing platform Linux BSD. Now I think I want to specify the architecture. Ow. Target editor. Architecture is x86 64. Let's see. So our mass spring damper has been compiled. Close that. Let's copy that to local opt Godot. With this system, you have some sort of motion physics loop for this limited motion that you repeat the motion for some amount of time, and then the spring hits an immovable stop point, or you multiply times -1 to change its direction after some number of loops, and then we're to stop after a few more cycles. So I thought the spring is to give your grabber a kind of tolerance for physics float shenanigans and weird angle shenanigans, right? Whereas a fixed grabber blows up more immediately, I'll think. Yeah, so for example, random, if the player grabbed a lever and they like pulled the lever, then this would work for that, but only like if they're holding the lever that's supposed to go backwards and the player moves right, what's going to happen? do I need to put in some because I guess the other thing I need to do is I need to stop the player from being able to move in certain directions they shouldn't go. Motion constraints. We'll add 2 more springs for those unit vectors. So yeah, like I would have motion constraints, but if I guess that's the part that starts that's where I really start tripping up, because like if I have this spring doing something and then I want to also tell the player they can't move a certain way. Would I tell the player that they can't move a certain way, or would I tell the object they're trying to move that it can't move a certain way? And then, based on the result of its update, prevent the player from moving. You know what I mean? Is only in this movement direction. Yeah, and then I need to do something on the player that says you can't move. Like, I need to restrict the player's. I guess that would depend. That would come down to the player, like holding onto the object. I'd have an inverse kinematic. I have an IK connecting the player's hand to that point, and then as the player turns, I'd need a way to like lock them in place, sort of thing. So like they can move around how they want, but the hand stays there. And if they turn in a way that's able to move the lever, then the lever moves. But if they turn in a way that can't move the lever, the hand would have to stay in position. So the hand would get its position from where it's grabbed the lever. So if the lever's able to move, the hand automatically moves. But if the lever doesn't move, the hand doesn't move. And then that is how we limit the player's movement. Okay. Oh my god, fucking why? Why did I choose to have this be the basis of my game? Why? Fuck was I thinking? I just. I need to. I think I need to learn some more. I need to relearn all of the fundamental physics and maths that I've forgotten. So if we have a shape block, and we go export a variable of no, actually we wouldn't do that. Would I? Would I create a spring on each object that we want to move? Or would I only create it for the player? So when the player grabs it, we create that spring object. And then when we move it, we tell the thing that it's moved or what its new position is. Yeah, that's what I'm thinking. Because the way I've set it up is oh, hello. It doesn't know what a mass spring damper is. And that's because I need to go into here. Need to go include the mass spring damper. Register class. Mass spring damper. Copy. Let's do that again. Rebuild. Looking forward to how it goes. Have a good one, Random. Thank you for the help. What is that? No matching function for call to mass spring damper. Register class creator. What? Oh, and his default. Yep. It needs default constructor. That should fix it. Yep. I hope. Beautiful. Okay. There we go. An export type can be built in a resource. Oh, damn it. Okay. So I can't have that as an export. What if I went export var spring objects. No. I did that. Yeah, okay. No, I didn't, Pixel. I have no idea what the hell that hinge joint does or how it works. It still confuses me. It doesn't rotate how I need it to. So I cry a little bit. So if I have this as an object and I instance it the player, I would need a resource or a ooh, maybe that's what I do. Oh, maybe that's what I do. Here we go. Here we go. Here we go. Here we go. We make it a ref counted. And if it's ref counted, no, that I still can't assign that as a resource, can I? Still can't assign that as a resource. But it's not like a resource is a ref counted, but a ref counted is not a resource. Yeah. All right. I'll just make you a resource then. Jesus Christ. Is your grabber spring a spring joint 3D or custom thing? My grabber spring will be this. So this spring will be used for multiple things, actually. It'll be our grabber spring. So, you know, the rest spring will be in the hand, and then it will like move towards the hand, sort of thing. But then we'll also be able to use it for other things, like if the player's pulling a lever and they let go halfway through, we can have a spring push the lever back to its original position, sort of thing. Stuff like that. That's why I wanted to go down this route, because it gives me something I can use for all of my different situations, rather than being like, for the lever, we do it this way and we lock this stuff and whatnot. Yeah. All right. Because I knew there was a way to do it. Excellent. So now I can create a mass spring damper. We set this stuff. We don't need the force amplitude or driving frequency at this point. It's really just like the mass, the spring strength, the stiffness type of thing. And the mass, set that like that. The stiffness, have that as like 3 or something. This here, I need to get that corrected up. How do we do that? Because that's something I've always had issue with, is getting them to appear. We go node. You'll notice there's like a process mode enum right there. Like, how is process mode? There's definitely a when paused and a pausable. That's why. I see why it's having an issue. So if we search when paused, that's what we want. That there's what we want. You add the property process mode. I have that here. Add property spring strength. Needs to be so node C++ 4046 int process mode property hint enum. Property hint enum, and then the string is a comma separated list of all the different options. Okay. Actually, no. Property hint none. Where was it? Property usage. So it is property Hinternom. This would be weakest, weak, medium, strong, strongest. If I'm right, that should give me a drop down. Did you go back to 10-hour streams? I've gone back to one stream a day, around 8 hours on average. Sometimes we go over that, sometimes it's less than that, but yeah. So let's see if that gives me a drop down. Aha! See? Beautiful. So if we have it set to weak, now one thing I'll need to do underneath my view pivot, for now I'm just going to create node 3D, which is just going to be bold. Do that. Got that notification stuff working with a save system. Nice. If player closes app by pressing X button top right or manually closing on Android, it triggers saves data before exiting. That's awesome. That's awesome. Yeah, the notification stuff does seem very, very good. It seems very powerful. So if we do that, I also want all of these. Because they are an interaction. We're also going to set them on interaction layer 6. The reason why we're setting them on interaction layer 6 as well is so that when we do our raycast, do I move that under here? No. There you go. If event is action interact event is pressed, we do raycast force update collision collision object 3D raycast get collider collision is null. Actually, it's not null. Then we can reparent to hold and go it's gonna only be rigid body 3Ds anyway. Collision. If we released, then we can go and held object is not null. Reparent to this is where it becomes a bit of an issue. I would need it to reparent back to its original parent, not just back to the world in general. So I don't want to do that. And go held object null. But we also want to go spring, mass spring damper. Clear those out. Linear velocity can be there's no velocity. So how could we keep it moving after we let it go? So if I pick something up, I guess if I'm not moving it, then it can just fall to the ground. It doesn't need to like slingshot past me if I stop picking it up. Then what we do under here is we go bring oh, that's right. The update spring update spring And what are the properties? Target, gravity, delta. Compile that again. Completely forgot about that. Completely forgot. I also keep forgetting the camera's up there, and I keep looking there for the camera, but it's up a little bit now. Whoops. Copy that over. Let's see what happens. Spring. Update spring. Global position. What up, Parker? How you doing? Gravity will be get gravity, and the delta will be state step. Now that's gonna be a problem. So this is why I can't just do that, and why I need to do mass spring damper new. Okay. I don't have a new function. Spring. Yeah, I'm gonna have to rework that. I'm gonna have to create two. I'm gonna have to create two things. One will be a spring. The other will be a resource that, like, the spring will be an object. The other will be a resource that has the details of the spring. So when I pick something up, I create a spring, give it an initial position, an initial velocity, all that stuff, and then I get the resource of the thing that we're picking up, the spring resource, and go, this is what your strength is, this is what your spring constant is, this is what your dampening ratio, all that kind of stuff. So I'll have to create that. We might do that tomorrow. I have a bug for Bobble Shop Sim that I need to fix tonight, so I'm probably not going to get around to that. Yeah, that's going to be a little bit of reworking, but that's probably like an hour of reworking at most. Let's see. So we'll call it there for the day. Thank you, Random, for all the assistance. I have this very old DDR2 era PC. How well does it work, Parker? Is it able to run 007? Like the new 007? It had 3 gigabytes until I found out the 2 gigabyte stick had died. Now it only has 1 gigabyte. Oh no. Oh no. That's not good. That's not good at all. Alright. Well, I will be back tomorrow. We'll hopefully be able to get this spring stuff tested and whatnot tomorrow. Hopefully. Hopefully. I will see you all then. All right, we'll go say hi to Chapel, who's doing some artwork. Toodles, you good dunce.